Okay, so welcome back, guys. Thanks for putting up with so much information in one day and very little breaks. Again, I'm going to do my little spiel on there's bathrooms by the elevators, there's stairs over by the elevators, or go out here, turn right if there's an emergency. If you smoke, you have to go outside in the southeast corner. I think that's about it. I will send around, again, a sign-in sheet if you need to get a certificate for being here, or AICP credits or GIS credits. Please sign this. And then I forgot the papers so that I could introduce Jim. Tell us about yourself, Jim. You want to introduce yourself?
Sure. My name is Jim Castaneri. I'm a geographer from the Office of the Census Bureau out of Denver. This is my 28th year as a geographer down there, and been doing these kinds of workshops for a long time, and this would be my second or third, maybe fourth time.
Second me,
with
but I've only been here 2 years, so. I met him in Colorado because that's where he's actually lives right now, too.
So thanks for having me back, and that's all you need to know about me, I suppose.
Okay, cool. So
I have questions for them whenever you're ready.
I am totally done now, so you have the floor.
Good, okay, so I'll stand back up again. I'll talk very loudly for those of you in the back. And first of all, realizing that some of you are here for the second half of the day of this stuff, that's crazy. I think I mentioned to some of you before. That's a lot of stuff to cover. You know, I was here for a little bit this morning and saw that you all were looking at ArcGIS online, and what we're going to talk about today is really doing that same kind of thing using ArcGIS desktop. So in a sense, we're kind of taking a step backward in time and using some older school technology. So two things you're going to need to know today are ArcGIS, desktop, and Excel. If you don't know either one of those two and you still want to participate, hopefully you can partner up with somebody who knows those two things. We're scheduled for 4 hours. We want to make sure you have adequate breaks. My feeling is anytime you have a question, please raise your hand. Anytime you need to leave the room, please do so. I will not be offended in any way. Leslie is going to interject whenever she needs to with questions from anybody who's online. And I know Mary's going to come down here in about an hour or so to talk with all of you. So we'll have some breaks and try to stir things up for you so you're not terribly bored. All of that said, how many of you are ArcGIS desktop users? Raise your hands. Okay, a lot of you are. That's good. I think those of you who are long-time users of desktop, you might find a lot of what I'm doing pretty mundane. I encourage you to take this time and forge ahead if you like. You should have an agenda. Do they have an agenda, Leslie?
Oh, you know what? They will shortly. Keep talking, Jim.
And then also, if you can think about this while you're doing that, they need a data set as well. And I know you did some copying of that.
Yes, so on your desktop, you should have a folder called Census, I think. If you click on that, it's like the AGO1. There should be a whole bunch of data in there.
NC data.
NC data, there you go.
Okay, I'm going to take a minute to, we're going to go over that, but first I want to get to know a little bit about all of you. Now, my screen is not going to look like yours because this is not a Montana laptop, it's a Census laptop. So that I know who is sitting here in the room with me, I would like to go around the room. Maybe you did this already this morning, but please tell me your name, where you're from, and what you'd like to get out of this afternoon's workshop, if you don't mind. So your name, where you're from, and what you'd like to learn today. Yes, sir.
I'm Eric Meredith. I'm from Helena here. I work for ArcGIS, and I am hoping to learn much as I can about ArcGIS.
Yes.
Diane Tappenauer, I work for the Montana State Library as a GIS analyst. I am hoping to learn more about census data and ArcGIS.
Excellent.
My name is David Fothergill. I work for the Forest Service, and I'm just curious about how to use census data.
Okay.
Ross Johnson, I work for the Legislative Audit Division. I'm there, and I want to find out how to use census data.
Excellent.
Jason Moore, Legislative Services, research analyst there, and I'm just here to learn and try to figure out ways that might help.
Okay.
Brett Holder with Trust Lands Management at DNRC, and trying to get into all kinds of data that I can find to pull into mapping.
Okay.
I'd like to know new ways of using the newest one. I'm very familiar with the old one.
I think I recognize you from last year. Nope, they haven't done that yet. How many were here last year for this similar workshop? A couple of you were? Okay.
John Olson, Vortex Tribe, Economic Development Planning Office, and I used desktop a little bit in grad school 5 years ago. So, how to create maps.
Okay. Good.
We'll be right Stanley from the Rural Economic Partnership, and I don't know much about this, but we get a lot of requests for information from businesses coming in Google, and I'd love to learn how to use that.
Okay.
Emily Fleming, Student Systems Foundation, and we're looking for some ways to collect better data for research and so the type of data for research.
Okay. Okay. That's
So I work for the VA, very data-rich organization, but it's been investigated other data outside our data sources to help us start planning.
okay.
Tract, transportation demand modeling at MCC, and specifically interested right now in employing employment and housing data.
Okay.
Stacey Anderson is from Geographic Hierarchy, and looking to learn a little more about how to take some of our data and out there.
Okay.
And Steve Gately, and I'm a land use planner from City Shelby. I actually have 3 things. One is relatively inexpensive applications for policies for small towns or rural areas. And we're redistricting our wards. City Shelby end up being on the places. I think public health and human services. Just curious how your take on that. My name is Drew Bailey. I'm a computer programmer. I work for SITXE. I'm on a few projects that are going to be using more and more GIS and other related data. So I just would like to learn. Robbie and I are with WWC Engineering here in town. We write a lot of growth policies. So
miss you? So tell me your name and where you're from and what you'd like to learn today.
How to, I need to know how to do the census data and GIS.
Okay.
Michael Stone, I work on the microfusion project. And I just like to learn how to use software.
Renee Lemon, Greg Westside here in Helena, and I was looking for better ways to access them.
Do you have an office in Denver?
Nate Rogers, Missoula County. Just want to learn how to use GIS for
Our conference is this week, but I want to know that Michael's talking about this. He does projects as well as
Ken's back there. So how many of you have joined a data set with a layer in ArcGIS desktop before? Okay, a lot of you have done that. I think for a lot of people, the biggest challenge in utilizing census data in desktop GIS is just finding the data that you need. And that really is a common theme, and as we've said, we were hoping when they redesigned FactFinder a few years ago, they would have made it a little bit easier to find not only the data, but the geographies that you need to get the job done. And that didn't happen, in my opinion, and a lot of other people's opinions. So today we're going to try to spend some time talking about how to find the data that you want, formatting it, and then ingesting it into ArcGIS. Now, I'm a geographer. Last year when I was here, I had my colleague who just retired 2 days ago, who was our data specialist. And because we had the furlough and the sequester, I wasn't even going to be here this year. There weren't going to be monies, but thanks to our partnership staff and the request from Montana Department of Commerce, I'm here on another department's dime. So I was the only one they could send, and since the focus was GIS, you get the geographer instead of the data guy. So I know a little bit about the data, and I'm going to pretend or maybe sound like I know a lot about error, but I don't.
How long have you been working again for them?
28 years. And you're
Well,
going to make me,
a lot more than me.
you're going to make me sound bad. Sometimes you spend a lot of time doing things that have little to do with what you're talking about. So we're going to start today. After hearing a little bit about all of you, I would like to take some time to talk about census geography. And I forget what all you all have in that folder, so you might have this already as a PowerPoint. You're certainly welcome to follow through on the screen.
You're talking about on the little folder on your desktop, you probably have this PowerPoint.
Yeah.
And also, just as a sub-note, all that data is, again, on the workshop page on CEIC site. There's also some CDs over on the table that Jim made with copies of the data. So don't worry about copying it. We can get it to you.
Almost everything, virtually everything on that disk is downloadable from the Census Bureau's website. I say virtually because maybe there's one or two things that are not. But one of the reasons we preloaded the data is that with all of us trying to grab the same data set at once, it might get a little problematic. So we went ahead and preloaded data. That's not to say we won't go ahead and go through the motions today. We'll just see how it works and see what happens. But before we can talk about the data, the demographic data, and before we can talk about the tiger, we really have to talk about census geography. That's really necessary in order for us to put into context all of the data that are available and how we might use that in a desktop GIS. So The foundation of all of the mapping, both internally and externally at the Census Bureau, is this thing called the Topologically Integrated Geographic Encoding and Referencing System, designed in the mid-1980s. It was an outgrowth of the GBF DIME file, if you're familiar with that one. We worked in collaboration with the USGS, raster scanning their 100,000 scale, 1 to 100,000 scale map series. They created DLGs, if you remember those, digital line graphs, and from that we created Tiger. So Tiger has its origins way back in the 80s through a cooperative effort with USGS, and here's my little plug that I've been giving ever since that time. Tiger was the very first national GIS in existence, not only in this country but in the world. It's still one of the largest seamless GIS databases in the world. It's not always the best for the applications at hand, but it has been a continuously operated GIS at Census. What we see as the public is an extract of the true Tiger system. And I won't get into a lot about that, but Tiger is integrated. We don't have layers in Tiger. It's all one interconnected web of topologically related nodes, lines, and polygons. So when we deal with our extract, our Tiger line products, we're dealing with a piece of that. So into census geography, there really are two major classes of census geography, and they are political and statistical. What's political geography? Well, the state of Montana is a political piece of geography. Counties, cities, American Indian reservations, and in the east, minor civil divisions or townships. Now in Alaska we have boroughs, in Louisiana we have parishes. These are county equivalents. So the Census Bureau likes to try to look at these as counties or county equivalents. Political boundaries may change between censuses depending on annexations at the city level. Sometimes counties change, not so often anymore, but there was a period of time in the 40s and 50s and 60s where new counties were being added all the time, particularly in the younger states. But in some of the older, more established states, and Montana certainly is one of those, the counties are somewhat fairly established. Still a fair amount of adjustment going on in places where counties follow rivers like the Missouri River, and there might have been a historical meander that was cut off at Oxbow Lake, and oftentimes throughout history the legal definition of the county is the river itself, and so when an Oxbow Lake gets cut off there has to be all these finaglings to get the boundary recorded appropriately. Does it stick with the original definition? And then they go to court because somebody argues, well, it says here it should follow the river, blah, blah, blah. You get the picture. Statistical geography. These are census tracts. Probably the most popular and recognizable. Census blocks are the smallest level of geography, statistical geography, that is available to the public. And there is no smaller level piece of geography at the Census Bureau. So this is it. It's as small as it gets. Voter districts, believe it or not, those are statistical. They're not political. Even though they serve a political purpose, they are statistical collections of geography. Traffic analysis zones, or TAZs, those are statistical geography. And by and large, statistical geography was designed to display census data at various levels, various geographic levels, for research, analysis, for the public good. And by and large, they do not change between censuses. Now, there are some situations where they do. Census tracts, the primary one that we're going to be talking about today because it's easier, they do not change between censuses. So they're established 1 or 2 years before Census Day, they're finalized, and they're stamped with an approval, and that tract doesn't change for 10 years. I don't know why I feel compelled to put this thing in here. It really doesn't make a whole lot of sense. At one point in time it probably did, but it's supposed to give you a graphic representation of the hierarchies how some things nest very nicely and some don't. The one thing to take away from all of this is that at the very bottom of this messy hierarchy are census blocks. So they are the foundation of all of the geographies, both political and statistical. You can see there's some straight lines in here of up from blocks or block groups, census tracts, counties, states, divisions, regions, and the nation. And then you've got some various and sundry political and statistical boundaries that nest sometimes and sometimes they don't. Statistical geographies, blocks, block groups, and tracts always nest within each other and within the county, and we're going to see some examples of that in a sec. Here we go. Because I figured I'd save what the work I already did. I did this presentation in Colorado a little while ago, and I figured rather than do one for Montana, I'd just reuse the Colorado slides that'll help you get the picture. State of Colorado, Denver County. Now, when you're doing joins with data, census data or any kind of data, you usually are not joining on the text field that names the attribute. And the reasons for that is the text oftentimes is too long, it might be confusing, and like everything else, the federal government applies code to everything. So you're all probably familiar with the FIPS coding scheme, the Federal Information Processing Standard. It's actually been usurped by ANSI, but for all practical purposes, FIPS codes for states, counties still apply. So the FIPS code for Colorado is 08. The FIPS code for Montana is 30 or 30. And notice I said 08. I really should have said 08. And that's going to be important for states like Colorado and Arizona, not so much for Montana because Montana is 30, but you'll see why in a little bit. Denver County also has a FIPS code, and it is 031. And there it sits within the outline of the state. Next slide, we zoom into Denver County, and we see the outlines of Denver. This is actually a little piece of Arapahoe County there. City of Glendale elected not to be incorporated into the county of Denver. So this happens quite a lot these days, and especially in high-growth urban areas, it becomes very problematic if your job is to enumerate populations and decide whether they live inside or outside of certain jurisdictions. I did a whole presentation at GIS in the Rockies last year where we talked about strip annexations, and a very popular thing to do for suburban cities is, and there used to be a game, and I'll need to look it up for myself to figure out the name of it, but in the 80s, remember the arcades? I was in college. I guess so, yeah, I was in college at the time. You could go to a video arcade and had all these machines in there, and you just pumped your quarters in, played Pac-Man and whatnot. There was one game where you drew a line against your partner, and the objective of the game was to keep your competitor from gaining space. And so you draw a line. He couldn't cross your line, so you draw a line and block out as much land as you could, and then he couldn't cross your line. So whoever ended up with the most land at the end of that game won. It's exactly what happens with cities in their annexations. They do strip annexations to prevent other cities from annexing that property because most states have a contiguity law that requires cities to have contiguous parcels of land. So in Colorado, recently, in Arizona throughout time, they would literally annex the surface of the roadway and annex the surface of the road out till they can pick up a shopping center, which is a tax base. And then they'd head west or east for a while and grab that road, and essentially they'd loop off a giant area. The neat thing for them, for the local governments, is you don't require public input on that kind of annexation. You can just do it. If you annex private property, you have to have public input. What they end up doing is creating these fences around these huge blocks of land. Once they've created that fence, no other local government can annex that inside part. So they play these games with each other, and it's great for them. They annex the surface of the street, and all of a sudden, they've got this property. Well, it wreaks havoc for anybody such as the Census Bureau who has to worry about whether somebody lives in that city or not. So this is kind of beside the point, but It's really interesting. If you know Morrison, Colorado, it's where Red Rocks is, where they do concerts. The city of Morrison, little tiny one-horse town. They have the largest police force per capita, certainly in Colorado, perhaps in the country. And the one reason they do is that they annexed all the roads within 15 miles of the city, which is this little tiny thing. And so people are driving to work along 285 or C470, and they get pulled over by a Morrison cop for speeding. They're like, Morrison, that's 10 miles away. Well, they annexed the surface of the road so they can issue tickets to these guys. Drives us crazy. But anyway, if you're trying to enumerate populations, these holes and strip annexations create real problems. Where it will apply to you is if you're using political geography in your join, you need to be aware. You're going to have holes, enclaves, exclaves in your political geography. That's one of the beauties of the statistical geography. Statistical geography is designed to be compact and homogeneous. So we'll get into more of that in a bit. They are. Yeah.
Did you say enclaves and enclaves?
Mm-hmm. Enclaves and exclaves. So here we have Denver County divided up into census tracts. Denver's county code, if we were to identify this county uniquely within a large database, you could pull it out of that list, the 3,142 counties in the country, or county equivalents, by looking up this code, 08031, Colorado, Denver County. This is tract 15 in Denver County. And you'll notice, as it's displayed here, it's got 2 leading zeros and 2 trailing zeros. And I called it tract 15. I'm going to move to the next slide and talk a bit more about that. This is that same tract, but now I've concatenated the state and county code onto the tract code. If you look at some of our printed reports, there aren't so many of those anymore, but sometimes we format the name of the tract using the old style, and it's easier to read that way. You'll often see just a 2-digit number for the tract, or a 1-digit number. Sometimes you'll see a tract with a decimal there. You might see tract 15.1 or 15.01. Tracts can be no more than 6 characters in the data, and you'll never see a tract larger than 9,999.99. That's just the way we designed it. And I'm not going to spend a lot of time talking about tracts, but there's a lot of history behind them. Actually, I do go into them here. But the thing to pay attention to here is the fact that we store the tract as a 6-character figure, and that we pad the beginning of the value and the end. If it's tract 15, it's going to appear in the data as 001500. When we put those two together, we get another string. Similar to the concept of the county, we now have a unique identifier for this tract from all of the tracts in the country. And those of you who work with doing the joins, you're starting to get the picture. All of a sudden, we have a unique identifier we can use to join to the data. So we've divided the tract into 2 block groups. This is state 8, county 031, tract 15, block group 3. And down to the block level, those of you who are interested in doing block level analysis, we now have a much larger number to deal with, but here's block 3001 within block group 3, and we take that and add it to the state county tract. We can throw away the block group because blocks are part of a block group. So this really is block 3001, part of block group 3. We now have a, 15 digits that's unique for this block in the entire country. So every block polygon in the country has a unique code assigned to it. And there are approximately 13 million blocks in the United States. So here is that block with the tracts in block showing for Denver County. Not a very good view there, but I'm going to talk a little bit about tracts because we're going to do our exercises with tracts today. We could use any geography we chose. Tracts, there's some reasons why I'm using tracts today. Primarily because they're one of the most reliable small levels of geography that we can get census data for. We start having issues with reliability and availability for census data, particularly with the American Community Survey below the tract level, and we'll talk more about that later. So if we're going to use tracts, we need to understand a little bit about them. The first census was 1790. There were some folks who decided that a simple enumeration wasn't good enough, actual counting wasn't good enough. We needed to decide where these people were located. And so in addition to the states that were in existence at the time, we actually had people worrying about whether people lived within a certain sanitary district. And if you're into GIS, you remember that famous cholera map in England. And this is really a fallout of that realization that the location of people is important for public health issues. In 1906, Dr. Walter Laidlaw suggested the delineation of permanent small geographic areas that would retain their boundaries between censuses. So unlike cities that can do strip annexations and block annexations, tracts would remain stable for the purposes of analyzing from one decade to the next changes in the demographics. So tracts, the whole idea of the census tract was to do demographic analysis. So he did, in 1910, divided New York City into districts and asked the census to do the same for 7 other cities. What census tracts weren't even our idea. Lesson here. Laidlaw came up with it. He published the data in 1920 for New York City. It was so popular that Howard Whipple came along and took it over. And then the Census Bureau realized in 1940 that, hey, this is a pretty good thing for our data. We need to incorporate it into an official program at the Census Bureau. So in 1940, the Census Bureau rolled out the Tract program for the entire country. Tracts were restricted at first to major metropolitan areas. So in our filing cabinets back in Denver, I've got the very first tract plan for Denver, Colorado, which was created in 1940, and it was just a description. I don't think you'll find one for any town in Montana probably until 1960, when we started expanding it to some of the smaller towns. But by the time 1990 rolled around, we established tracts or block numbering areas for the entire country. One of the reasons tracts were restricted to metropolitan areas is that there are minimum criteria for their establishment. First of all, there needs to be at least 24 or 2,500 people. I'm going to get that number wrong. There's a maximum of 8,000 with a target of around 4,000 people in each tract. We want the tracts to be compact. We don't want them long and snake-like. We want them as compact as possible. We also want them homogeneous. We want to differentiate between industrial and non-industrial, between poor and wealthy. We actually design tract plans to segregate, if you will, and there's a purpose for that. So in 2000, the B&A was dropped. The whole concept of block numbering area was dropped, and the entire country was defined with census tracts. So you can get tracts or tract equivalents back to 1990 for the whole country, but they do not exist before that for the entire country, only for the large metropolitan areas. If tracts don't exist for an area, then neither do block groups and neither do census blocks. So if you're looking for fine block level data, which you can get from 2010, 2000, 1990, but you want it earlier than that, you're probably not going to find it anywhere in Montana. It doesn't exist and never will. In some cities, it may exist. It depends on whether or not the tract plan was created and whether or not a block plan was put together. Yes. Yes, it goes quite a ways back. And there, if you're familiar with the National Historical GIS Project out of, is it Minnesota? They've got a lot of the historical tracts with data attached already. So you should check it out if that is an interest of yours, and it is of mine. You'll find some really interesting, they have the shape files there and an associated data as well that you can compare that. And that was the design of the program at the beginning, in the first place, compare from one decade to the next.
It's pretty fascinating or interesting that the timing coincides pretty much with the population or the popularity of zoning.
Uh-huh.
2020.
That's a very good point. You know, it's interesting that you mentioned that to live in a state like Colorado that has a fairly rigid zoning process and to go to a state like Texas that does not. And you all recall the fertilizer plant explosion down there where they had the daycare and elementary school within a couple hundred yards. That would never happen in Colorado because zoning. Some people think, well, maybe it's not a good idea to put a bomb factory next to a playground. This is an actual tract out of Utah, and I don't know why I chose Utah. This is, again, one of those slides I've reused over the years. In 1970, the tract plan in the Utah Sawatch Front, this particular area was known as Tract 1130. And for the 1980 census, that tract experienced population growth. You might not have seen, but I'm going to back up here. So there's this area of prairie grass, which I will admit I doctored this image to illustrate the point, because you can't get Landsat, and well, you couldn't get Landsat back in 1970, but I didn't have access to Landsat before, say, 9 years or so. But that's a real image with some doctoring done to it to show that in 1980 there was a little bit of growth, and so the population in the entire tract surged, and because it went over the maximum, the design of the tract program is that tract has to be split. Now we're talking about this because at some point when you start working with tract data in your GIS, you may run into an issue with suffixes. Where did they come from? What do they mean? How do they work? Blah, blah, blah. And that's what this whole discussion is about, tract suffixes. Tract 1130 was divided into to approximate equal portions for each piece. We also look at land use pattern. Now, is this area commercial or industrial? Is this area residential? That kind of thing. We try to take those kinds of things into consideration. I say we. In fact, in today's plans, local governments are in charge of defining their tract plans. So in Montana, we contact every county or planning agency in the state each 10 years to talk to them about redesigning their tracts for the next census. So really it's the local planning organizations, the counties, and sometimes the state who get involved to define the tracts for their jurisdictions. The Census Bureau then receives those plans from local governments and reviews them and approves them.
Just as a side note, Erin, who presented in the morning, she's the one that works on that at the state level for us.
So in 1980, 1130 was divided into two pieces. Not sure who came up with this plan, but the realization was that in order to go back and do some comparability in the data, we needed to preserve the original tract boundary somehow. So really, the original border of Tract 1130 has not changed, the outer boundary of it. All we've done is split it in two. So by keeping the original number and adding a suffix, we can identify the two pieces that made up the original tract number. So if we throw away, well, if we combine these two together, maybe I was just born in 1980, I don't know anything different. Just looking at these numbers, I'd say, oh, well, this used to be Tract 1130 10 years ago. Well, then 1990 comes along, and there's been more growth. And this is a real example. I doctored the image, but not the boundaries. So all of a sudden, we've had more growth in those two pieces, and we needed to further split them. Notice you won't see 1130.01 and 1130.02. Why?
Different boundaries.
That's right. They've been used. They're different boundaries. if we had left one of these pieces as 1130.01, it would imply that the tract hadn't changed. And this is a very important concept of the whole program. If you see a tract number from one census to the next, the number has not changed, and you can be pretty darn confident that that boundary has not changed. We do have a rule that says if the tract changes by more than 5%, then the number has to be changed. And there's some reasons why the boundary might have to change, and we won't go into all of those. But so if the boundary remains roughly the same, then you can keep the number. If you split it, you've got to renumber. So 01 and 02 have been tossed out. I think this was 01 before, whichever, doesn't matter. It now becomes 03 and 04, and then 05 and 06. Well, guess what? Split again. Now, I didn't do the latest one, but I'd be willing to bet they split even further. So this is the last time I did it. Now it's getting to be a little messy, isn't it? Believe it or not, there are places in the country where we've split the tract so many times there are no more of these numbers. And Phoenix is a real good example. It actually happened in Denver this last census. We had to go through the Denver Regional Council of Governments and sit down and define a new number plan for the entire southeastern, the Aurora portion of the metro area, because they had run out of tract suffixes. That original tract 79 grew so much and was split so many times, there were no more 0.99 when you were done. So we got a new numbering series for that part of Denver. Anyway, you can see the point here. The original boundary is still there. If I wanted to compare this whole area, maybe this area is known as South Valley West. You know, like I say, the population in 2000 is this, based on an assemblage of these tracts. I can compare it directly to that same area in 1970 by looking at that tract number. So that's the concept of a tract. That's the purpose of them, why they were developed, and understanding that about them now, why you have 6 characters. The decimal never appears in the data. So if it's tract 1130.01, it will appear as 113001 in the data. Any questions about the tracts?
So there's different situations where you'll see the decimal and other situations where you won't.
The time you would see the decimal is in the name. So, for example, in our data products where you're looking at income, there's always a field name, a value that lets you identify it uniquely. It's code. Then we would define that code as median income for 2012. That's what, when you see the tract number, because we also define the tract. You would see the number 1130, that long string, and then there would be a field definition where it would list Census Tract 1130.01. It'd be the text definition of that tract.
It's the same as the county name.
Right.
The tract.
Good example.
Text
So you
versus
have the GeoID.
okay versus
You
an ID.
have
Yep.
name.
Yep.
Good. Thank you. Yes, sir.
So let's say, like South Valley, West, or whatever, experience population loss. Would you then recreate the old census ones and you get 0.01 back? Or?
That's a very good question. I've never had that one before. I've had the question of what happens when the population shrinks, but I've never heard someone ask the question about reusing numbers. Generally, we will never reuse a number. It's been done by mistake for exactly that reason, and it's slipped through sometimes, so you may find it in our data if you look hard enough. Because of the change, we would discourage the reuse of a number, even if it was available and it would make some sense, because that would suggest no change in the data, and we don't want to do that. We want to make sure we record the change. But yes, if there is a shrinkage, if there's gentrification going on, we will combine tracts. Often, it's not a very neat process. When you start combining tracts, you can start losing the originals. Like if, say, one of those suffix tracts decreased significantly in population, and there was an area next to it that was not part of that original tract. It's conceivable those two areas could get merged into an entirely new tract with a new number series. And that would be that decision would be based on a lot of communication between the local planning organization and the Census Bureau. Oftentimes, planning committees, and they're supposed to be committees, they'll sit down and say, hey, look, we use this tract data for transportation planning, for housing planning, for low-income planning, for all kinds of things, and it makes no sense to have a boundary between these two areas because they're really the same. They're both blighted. They're both part of the same community. They need to be one tract. They would argue that to us, and we'd look and we'd say, okay, we agree. And so, boom, one tract. That happens all the time. Well, it happens. And those are the kinds of discussions we like having at the Census Bureau because we want the tract plan to meet the needs of the local community. And if you're a geographer, that's the fun part because you actually get to go down there and look at the land use and look at what's going on, see if that kind of merger makes some sense. Other questions about tracts?
There's some kind of table that will show you between censuses to make that this tract is not these tracts.
There is a census tract, I'm forgetting the name of it, that will list just that will list this census tract numbers and the previous census tract numbers. I want to say equivalency table, but that's not right. It's buried fairly deeply in our data sets, so if you go looking for it, you probably find it before I would, but it is there. More often than not, the way that geographers find those situations is we overlay them in the GIS. You've got that visual.
But the ones that it's like I can see the one on the bill, like add them all together. But if they tell me numbers.
Yes, then we do have an errata sheet after each census to talk about which tracts have been merged and the numbering schemes have changed. So for Phoenix and Denver, where we had huge numbering schemes change, we actually listed all the old series that were gone and the new series. So in Denver, there's a new 300 series. The biggest tract number in Denver, I think, was 129, whole number. There were lots of little splits. So we jumped all the way to 300 for that southeastern portion. And then because of Broomfield, and don't get me started on that one, a new county down there, we gave them a whole new series of tract numbers. It's not so much about the geography associated with it. As a geographer, and as a citizen, a tax-paying citizen, you know about the issues associated with new counties and new cities, and you know about the need for services like fire, rescue, taxation. And when you see the public press releases on why Aurora needs to be its own county or why northeastern Colorado wants its own state, it's ridiculous. It's people who have the public forum who say we need our own state or we need our own county, and people go for it, and it's not for the right reasons. You know, I live in a part of town where we're unincorporated, and the fire district covers little pieces here and there, little enclaves surrounded by another fire district. And, you know, there's a firehouse right here, and literally the block over, that house is not protected by that firehouse. That's ridiculous. Why? Because of this situation where you have incorporations with the city of Lakewood, city of Littleton, city of Denver, and they all fight over their jurisdiction. If things go well, the fire districts talk and say, okay, this doesn't make any sense. We'll cover your part of the city if you cover this part of our area. But that doesn't always happen. So the people who suffer is the public. And I could go on and on about that, but it happens all the time in places like Colorado and Arizona. And it causes all kinds of problems in GIS as well. So, I want to talk about where to get the Tiger data. You know, we abbreviate the definition of the whole series of products related to Tiger. I say just Tiger, but really I should be calling them Math Tiger and TigerLine shapefiles and TigerLine geodatabases. There are a lot of different iterations of these data these days, and I'm going to talk about those now. When I say Tiger in a public setting, I'm talking about any number of products that are built from our Tiger system. But you need to be aware that there are a lot of options open to you as users, data users, about how to go about getting the data that you need. I am doing a presentation tomorrow on some new developments at Census. I'm going to talk about Tiger Web a little bit more and do a demo of it, and I'm going to talk about the Census API a little bit. More along the lines of what you all talked about this morning, about doing online GIS with ArcGIS Online. That's kind of the focus there. So we are dealing with desktop issues here, but I'm going to mention some of these other products that are out there. As most of you probably know, with your desktop GIS, you can integrate online web services into your desktop. So I would be doing you a disservice if I don't mention Tiger Web, which is the Census Bureau's web mapping service. Almost every piece of geography, both political and statistical, that's available at the Census Bureau can be ingested as a web service from the Census Bureau. And if you're, if I have a reminder, I'll point that out to you when we actually go live on the website. But you can find everything geography related on the Census Bureau's main page. Right in the middle of the ribbon of the different departments, there's a geography right there. And you click on or hover on that, and you'll see Tiger. And you'll find everything about Tiger in that one place. So it's kind of hard to miss. We're not going to talk a lot about Tiger Web today because you talked a lot about that this morning. Tomorrow I'm going to talk about some possibilities of Tiger Web and the Census API. I want to focus more on the TigerLine shapefiles and the TigerLine geodatabases. Shapefiles really came out in 2007. Before that, we had TigerLine ASCII files. They were just text files that you had to import into your GIS to use. After enough suggestion and complaint, Census said, hey, let's just start making shapefiles. People will be happier. And then 10 years later, they said, hey, let's just start making geodatabases. People will be happier. And then they said, why don't we just start adding some demographic data to these shapefiles, pre-joining the data? So we started doing that. The problem, though, is that there are thousands and thousands of variables available from the census itself and from the American Community Survey and from the Current Population Survey and from the American Housing Survey and from the Survey of Income and Program Participation, and blah, blah, blah. So anyway, the point is we couldn't put everything in a pre-joined fashion up there. This is a select set of demographic data pre-joined to both shapefiles and geodatabases, and we're going to look at those in more detail this afternoon to see what's in there. Probably, well, maybe it has what you need already. You might not have to do any joins. You can choose shapefiles or geodatabases, and you know, being an old school guy, I've been using shapefiles most of my career, and it's hard to break out of them, but there really are good reasons to start using file geodatabases. They work much better when they're large. And you can get some of our newest geodatabases cover the entire country. So they're pretty large data sets. So I need to also let you know about updates to the Tiger system data products. And Aaron could talk to you a lot about this one. These primarily serve for the geography updates at Census, but they also serve a purpose for the tabulation of the data products. Now, you've heard, I think, by now that our BAS for 2014 has been canceled due to the budget cuts. I don't think too many governments are going to be crying about that. Some that have incorporated recently might be upset that those new incorporations will not reflect their new data estimates with the proper boundaries for at least a year, maybe longer. That might be an issue, particularly if you're applying for a grant, a federal grant that looks at your population or other criteria based on your boundary. But that's not a lot of different jurisdictions. Normally, we conduct the BAS, the Boundary Annexation Survey, every year, and some of you may be familiar with it. I've worked with a lot of the governments in Montana on this program. where we ask for GIS coverages showing their boundaries. We try to ingest those boundaries into Tiger as best we can and reflect those same boundaries in the Tiger system for the purposes of allocation of population and housing units. So obviously for American Community Survey and the decennial census, having a good boundary is important to having good data. Those of you who are looking for block level data, the smallest level of geography, and looking for pop and housing, the redistricting data program, as the name implies, was created for the purpose of redistricting at both the state and the national level. And a little fact I'd like to point out about Public Law 94171, I'm going to get the date wrong for this one. I can't remember the date at which the Congress passed that law. I think it was 1976. The census had been producing somewhat coarse-level data for the states for quite some time. And the states have had, since the beginning, the requirement to do redistricting. And so has the federal congressional seats. The problem was, I'm going to stand over here for a little while, that the data were so coarse that the states were struggling to define boundaries at equal sizes. So it was really the states came to the Census Bureau in the 70s and said, you know what, if we're going to do this redistricting thing, you've got to give us better data. We can't do it with Lewis and Clark County, total pop. Gallatin County, total pop. That's worthless to us. So that, believe it or not, that was the genesis of the small geography and of Tiger itself. We would not have produced Tiger if it were not for Public Law 94171. So it wasn't our idea. Thank you. So the whole small level of geography came from the needs of the user at the state level. We want to be able to do a better job of redistricting. And I was reminded it was 1975 was this law was passed. So since that time, we've been generating smaller level geography data and releasing it to the public. You can now download a geodatabase for your whole state that has block level pop and housing counts in it. Not much more than that, but you can get that. The PSAP program, before I change slides, Participant Statistical Areas Program, is that official name that we give to the Tract program. The program which redefines the tracts once every 10 years. Oh, I guess if I would have read my slide, I would have known it was 1975. So, in summary, Tiger holds all of census geography, both the political and the statistical. If you've worked with us in the past, if you're a federal or a state agency, you may have talked about or heard discussions of the federal agencies not working together and sharing data. Why does Census Bureau make Tiger while the USGS makes the national map, while they also produce the NHD, the hydrologic data set, and you've got FEMA doing flood maps? Why do all you federal agencies do all these different mapping things? And believe me, there have been decades of discussion about the federal government collaborating on one master data set. And the simple fact remains there are business needs in each of our agencies that other agencies aren't willing to pay for. For example, about 15 years ago when I think it was Clinton signed, renewed the Circular A16, which said federal agencies need to start working together, the Department of Transportation, the Federal Department of Transportation, has the responsibility to maintain the road center line. Census said, hey, so here, you guys going to do all the roads? No. Well, why not? Well, we don't have the money to do it, and we don't have the need to do it. The census had the need to have the roads. Why do we have the need to have the roads? Because roads are block boundaries. Why are roads block boundaries? They don't move. And if you're taking a census, and with all the technology that we've got, we still have to hire around 350,000 take the census. Even with the technology, even with the internet response, there are still people who will not answer, and we have to go door to door. If you do that, for 2010, we hired over 350,000 people to do it. You're not going to get mappers for all 350,000 of those. You're going to get people who, some of them, barely read a map. So one of the requirements of the census geography is that boundaries are easily identified. So all paved roads are, by definition, census block boundaries. Most major streams are census block boundaries. All political boundaries are also block boundaries. So if you remember back to that, it wasn't really a pyramid, but blocks were at the bottom of that web. Anytime a city incorporates a new area that we didn't have a boundary for, that new boundary splits a block and creates a new block. Anytime we define a new tract, we create a new set of blocks. Blocks change every 10 years. We don't keep block numbers. You cannot compare block 1003 from 2010 to the same block number in the same county next time. We make no effort to keep the same block number. We don't even pretend. Not the idea of a block. It's not to say that you won't run into blocks that are exactly the same, physically. And they may even have the same number. More often than not, you'll have the exact same block, exact same boundaries, but it's got a new number for this decade. You can't really compare blocks most of the time.
And that's just to provide the flexibility that you need because the landscape's changing.
Yes.
There's people in the landscape.
Right.
Okay.
So, despite that, every piece of geography, both political and statistical, have a unique identifier that's used to identify it. And that is what you need to pick out after you decide your geography in order to do your join. So a lot of blah, blah, blah to talk about joining data. So that was the end of we're doing 2 PowerPoints today. That was the first one. The last one's at the end, and we're going to talk about error. Maybe we can get there. Any questions about census geography? If you all can go another 25 minutes, we're going to take a break. Is that all right? So we're going to need 2 software tools to do the work, and I'm going to take a minute to talk about them. ArcGIS Desktop, and I just put 10.1 on my agenda. Anything 10.0 or above will be fine. There are enough changes after 9 something that things are different. But make sure you have your ArcGIS on your desktop ready to roll, and we're going to use Excel. I'm going to take a minute to talk about why. If you've done database management, you know that a spreadsheet is not the best tool to manage large databases in. And in fact, before Office 2010, I didn't use Excel myself because of the way I processed census data for GIS was usually many, many, many records. And as you know, spreadsheets were never designed to hold many, many, many records. So there are limitations to spreadsheets. Well, Microsoft expanded the capabilities of Excel and gave it some more flexibility. Excel excels at importing comma delimited files, and I found that very few people work with relational databases compared to the number of people who work with spreadsheets. So my preference is to use databases, but most people know spreadsheets, so we're going to use Excel today. Some of you who have done this work before might know that there's a tool, and I may get into this at some point, but since we're on the subject at the moment, there is a data download tool for census data for American Fact Finder that is an Excel macro. It works for 2007 and newer versions of Excel. So there are menu options that let you pick and find your variables, and it works really slick. The resulting data file won't work with GIS because they don't pull out that code from the data set. When they pull it down, they pull the variables, you get the number, total pop, Census Tract 103.00. You get the text. You don't get the geo-identifiers. You can't join the data using that tool. So, another thing. Ideally, you'd be able to download the census data from FactFinder, for example. FactFinder has a large volume of our data. Of all the data that's available, FactFinder has the majority of it embedded in it. If you download the data, you can choose an Excel file or a CSV file. Those files, formatted as they are not ready to be joined to ArcGIS. You would think that you could say, I want to use this with GIS, click, and send it to me in a format that's pre-formatted. They do pre-format it, but you have to work with the data a little bit beforehand to make it go. Unfortunately, what are some problems with that? And I'm going to get them ahead of myself, so I'm going to stop there for a moment. So let's go online for a minute. And I'm going to sit down now. We're going to look at the data. So if you want to start your browser, doesn't matter which one. I'm a fan of Firefox.
Can you characterize, big picture, the difference between American FactFinder and American Community Survey? I mean, is one a tool and one is the numbers?
Correct,
okay.
Basically. We call it the ACS, the American Community Survey. It literally is a monthly survey that we conduct. The Census Bureau, and now is as good a time as any to tell you, the Census Bureau replaced the old long-form questionnaire from past censuses with a monthly survey called the American Community Survey. And that is not on my agenda, so it was a good question and it's a good timely issue to discuss here. You think you're covering everything and you're not. How many of you care about total population? Sometimes we do. How many care about occupation and education and journey to work data? A lot more people. That doesn't come from the census. It used to. But what happened is in the 90s, a number of people started saying, hey, this data is great, but it's old. You've got 1990 long-form information that talks about occupation and income and education, but that was 7 years ago. This data is stale. Oh, well, do what you can with it. Maybe the state has done some estimates, and states do that. They take the data and they'll do projections and estimates. Well, after enough time went by, some folks thought it would be a good idea if we tried to create fresher data. So after Congress approved the effort in the late 90s, we did some tests in the mid-90s for this American Community Survey, and for 2000, actually we had the long form in 2000, but we were also conducting the ACS at the same time. That upset some people because they answered both the American Community Survey questions and the long form, but we dropped the long form for 2010. That meant that all of those questions about income and occupation and journey to work, those are no longer in the decennial census questions. Those are only part of the American Community Survey. It's a monthly survey, and I'm going to forget how many housing units. It's on the order of 180,000 a month nationwide. The sample size is much smaller. I shouldn't say much smaller. It's not quite an order of magnitude smaller than the long-form questionnaire, and I have a slide presentation later that will talk about that. But that has ramifications to you as a data user. So you might be inclined to take income data from 2000 from the long-form census and compare it to the same tract for 2010 using the ACS data, but you would not be comparing apples to apples. And we're going to talk a little bit about that too. So the American Community Survey now is the genesis of all of the most interesting census data. the occupation, the journey to work, the education. And in fact, I have our example today is home heating fuel. We're going to look at that. When we do our exercises today, you can choose whatever variable you want. And those of you who are familiar with the process, I encourage you to dive in. If you learn something today and you think, I want to look into it, go right ahead. Those of you who want to follow along with the examples, you're welcome to do that as well. So that covered. Let's look at under geography right here in the middle. And I don't know how fast this thing works for the folks who might be online, so I'm going to go a little slower than I normally would. If you
what we're seeing should be
what they see? Okay. Down here near the bottom is Tiger. And as I mentioned earlier, no thank you. This page has everything that you can possibly learn about Tiger is on this page. If it's not here, it doesn't exist. Doesn't mean you can find it easy, but it's here. So we have, now I'm going to use the laser pointer. Shapefiles, the newest ones here. We have geodatabases in the second bullet. We have shapefiles in geodatabases with pre-join data. We have cartographic boundary files. These KML prototype files, I don't think you'll see them anymore being freshened or updated. There were a number of new products that were put out a year or two ago with the idea of seeing what the demand was. And there's been some demand for these, but very little. And then Tiger Web. The cartographic boundary files, the intention for those is as a mapping extract. So if you're interested in just making a nice map and you want to have a boundary for things to show on the map, that's what those are for. Those of you who know Tiger, you know its history, you might know that the accuracy of Tiger is in question at certain times in certain locations. In terms of boundaries, even so. However, at a national scale, there is no more accurate database out there at any federal level. You have the USGS doing their thing, FEMA, everybody else. Whether you're happy or not with what Tiger looks like, it's still the most up-to-date and accurate in terms of the political boundaries that you'll find. Unless you go straight to the state, which here in Montana you have a fantastic program at the state for GIS data, boundary data in particular. Certainly we're not going to have that much detail. It's our goal to be within lockstep with the states on these kinds of things. And that's one of the things I am working on now at Census, is establishing those relationships with governments so that when boundaries are changed at the local level and the states recognize it in their data sets, Census is able to ingest it within a matter of months. All that said, sure.
And also on that note, again, Aaron is working with the Census on a pilot project so that our state boundaries are used by the Census Bureau so that they will all be the same. So that you can compare our state data to Census data, everything will be the same. So we're like one of, I think, 2 or 3 states that are doing this project. So it's really cool.
It is a very neat thing for us as well because there are 63 odd thousand governments in this country, political governments, and we have to survey them every other year for the boundary survey, and that's a lot of work. If Montana State can take 3,000 or 4,000 of those away from us, that would be great. So we're doing that with Montana, Utah, Maryland, and I'm forgetting the other state at the moment. And we're working on it with Colorado and a few other states. So hopefully we get there. Point is, these data are fairly up to date. If you click on the Tigerline shapefiles, you'll see down here that there are tabs for the different versions. And we were toying with doing 2 releases a year. I think we've settled down now to 1 Tigerline product release each year. And that's almost as frequent as we collect the data. I say almost, I should say virtually as frequently as we collect the data. So you're getting almost the best stuff possible. Now, if you're familiar with the national map and the geodata.gov and the concept, the whole notion that data are served live from the source, we're not there yet with census because it has to be QC'd, it has to come in and be adjudicated with the demographic data, with the type of topology. And so when we get data from local governments, particularly boundary data, it still has to be adjudicated within our system. Once that's done, we release a new product. So you will find that our boundaries don't match exactly what the state has, but you will find that it's very, very close in almost all cases. And that goes for all states. So I can click on this download hyperlink here, and I have a choice of going through a web interface or an FTP interface. I just clicked on the web interface, and this is where it doesn't make a lot of sense the way they organize this, but I clicked on 2013 Tigerline shapefiles, and now I'm offered this drop-down, select a layer type. And a while ago, we stopped offering the entire data set that was available because people weren't using it. We started offering themes of data. What that requires of us is to extract that theme from the master database. And you can see the results of those themes listed here. And they're alphabetical. American Indian Area Geography. These are reservations. Census blocks, block groups, tracts, congressional districts, consolidated cities, CBSAs, core-based statistical areas, used to be MSAs, metropolitan statistical areas, counties and county equivalents, county subdivisions, not so popular here in the West. Estate, I don't even know what that is. I'm a geographer. Sounds like my son. He said, I don't even know what that is, Dad. Places, public micro-use data areas, school districts, blah, blah, blah. Go on down. Those are all aerial geographies. Oh, by the way, zip code tabulation areas, I should mention these for a sec, because if we're joining to data, you should know about these. And there's another thing I missed. A lot of times if you're marketing or you're in market research, you talk to people, they don't know what the heck a census tract is. Everybody knows what a zip code is. So partly for that reason, the Census Bureau created zip code tabulation areas, ZICTA, we call them ZICTAs. They're not zip codes, they're approximations of zip codes. Now a word about zip codes, because you need to understand the difference between these. What we did is we approximated the boundary of a zip code to those census blocks that fall within that area. So we looked at all of the mailable addresses in the database of Tiger in our master address file, which is different than Tiger, and they're all assigned to a block. Where 90% of those addresses belong to have a single zip code, we assigned that polygon that zip code. And where they all came together in one, we dissolved them into a ZICTA. You're saying, okay, sounds great. Why doesn't it look just like zip codes? Zip codes are not designed at the post office to be aerial. They literally are not designed to be areas. ZIP is the Zone Improvement Program, and the idea was in the 60s is it would help the post office deliver the mail. They weren't thinking about nice, neat boundaries when they defined zip codes. So if you look at the actual delivery points for a zip code, a lot of them follow roads on one side of the road out for several miles. And the other side of the road could be a different zip code. And then the street right next to it could have houses that are in a different zip code. So zip codes are very difficult to define on the ground using a specific spatial geography. I'm not saying that's bad. It serves the purposes of the post office. What I'm saying is that for ZICTA, we've approximated those delivery areas in polygons made up of census blocks. Still works very nicely for marketing. You want to attach zip code data to something on a map that matches census geography, ZICTAs are the thing you want to use. If you want to compare zip code data to census geography, ZICTAs are going to let you do that. Okay, leaving aerial features behind, we have linear features. The all lines, this probably can't see that too well, but the all lines layer is the closest thing that you can get to getting all of the real Tiger data. All lines is, in a sense, everything smashed together, integrated. And so you have to look at the Map Tiger Census Feature Class Code to pull out the roads and the streams and the boundaries and so forth. So if you wanted absolutely every feature from Tiger, that all lines layer will give you every feature. But then it's up to you to separate the classes of feature types. Coastline was a new product. We've had a lot of people complain. Your census tracts go out into the bay. They don't show me the true density. And so we said, okay, without going into a long discussion on the reason why we did that, we said we'll offer a coastline layer, and you can slice it, overlay it, and trim it. Point landmarks. There are point landmarks in Tiger, not nearly as many as in Google, but they are there. Roads, rails, military installations. Those are really area polygons. I don't know why they're listed there. And the relationship file, that was the one. I've not done a lot of research, but this relationship file will tell you about how one set of features relates to another. Oftentimes it'll put a list of census tracts and a list of other geographies that are related to that census tract. I should probably look at those someday to see in more detail what they are, but not for today. So those were shapefiles. TigerLine geodatabases. Let's look at these for a second. Notice under this download it says, these files are large. Select a layer below or connect directly to FTP. They're compressed. We suggest you access these files using an FTP client. You don't have to if you've got a super fast internet connection, but you can see some file sizes up here. This is new. Address Ranges National Geodatabase. If you're into making your own geocoder, this could be useful. It's 0.5 GB. Here is the entire coverage for American Indian reservations in one geodatabases. The entire hydrographic database, which, by the way, includes a good chunk of the NHD, the National Hydrographic Data Set. And in 2 minutes, we'll have Mary talk. We've got a national census block geodatabase, an edges geodatabase, and you can see the rest of them here. Now, these don't have any data attached to them. They're just geodatabases. But as I mentioned before, if you're going to do a large spatially distributed analysis, you really should be using the geodatabases for your analysis. Shapefiles will slow you down and clog your arteries, so don't do it. These state-level geodatabases are pretty slick because they contain a multitude of geographies inside one geodatabase. And on your sample disk, you've got the Montana version in that folder that Leslie talked about. So I've already downloaded Montana. If you want to do it again, you can. I don't know what that'll do for our bandwidth here. I'm going to go back now, and I'm going to talk about pre-join data real briefly. And this is where we get into some more detail about the different levels of geography that you have available. And after this, we're going to listen to Mary and take a break. This will be enough for a period. We've got, let me point out what we've got here so it's clear. This file at the bottom here, 2010 Census Population and Housing and Accounts by Block, is state-level redistricting data that you can pull down as a geodatabase ready to use with pop and housing. The demographic profile in a geodatabase is 100% data. I say 100%, that's really an old term. This is Census 2010 data directly. There's no ACS data in it, but it's got a variety of population and housing data in there at various levels of geography. It's not everything, it's a subset, but I encourage you to peruse it and see if it's got data in there that you might like. There is going to be a data dictionary under each one of these. You have to kind of dig to find it. So for each one of these pre-joins, they list the data dictionary, which lists which variables are in those geodatabases. Some interesting ones are the ACS geodatabases. There's both a data profile and then a block group level database for both the 2006-2010 5-year programs and the 2007 to 2011 5-year programs. And I don't want to get into a long, detailed discussion about that, but we're going to have to at some point here very quickly talk about why, when you're doing small-level geographic analysis with ACS data, you've got to use the 5-year estimates. Most of you probably, or many of you already know this, but because of the small sample size, there has to be a longer period of assessment of data collection before we can release statistically sound data for a small piece of geography. And we'll talk more about that in the here demonstration this afternoon. Incidentally, a lot of the block group level data is not available under Fact Finder. There's such a high level of error in some of these variables that we just didn't feel good about making it easily available. Some of it is here in these geodatabases. You can get the full data sets via FTP, but be aware, any time you're doing block group analysis with ACS data, you're dealing with huge margins of error. We're going to talk about that. One of the things we'll finish up today.
After an ACS, like when the 2008, 2012, how long does it take?
That's a good question. You know, the data product itself is released the day of the announcement. These products are created by our geography division staff, and it's not a requirement as part of the program. They're just as a, you know, I'm not sure exactly when these came out. I think it was about 6 months later, roughly. And I know that would be their target because they actually use the products just like the public would to create the geodatabase. And then they do quality control, so it takes a little while to do it. So, there's yours.
Thank you. Those of you that don't know me, I'm Mary.
You guys heard about what do they call them when you find something in a game that wasn't expected? It's called a Easter egg. You guys got an Easter egg, and I didn't intend for it to happen, but it did. I was talking about working with large data sets. I was looking at preparing for this workshop. Sometimes you focus so much on census data, or at least I do, you kind of wonder what other kinds of data are available. And poking around a little bit, I stumbled across a data set that I started playing around with. Well, I inadvertently put it on the disk, which whether it got copied up to the network or not, if everything on the disk was...
Yeah, it just got copied to those computers, so everything's
So
there.
I'll tell you about the data set in a minute. This is the percent of smokers in the country by county, by 3,142 counties, I think.
Wow.
And it doesn't show up so well, but there's somewhat of a high density swath going through the Appalachia area here. And then some interesting patterns in certain areas of the country, a lot of which correspond with American Indian reservations. So that data, along with a whole bunch of other data, is inadvertently on your disk, and I'm going to show it to you now. It's the 2013 County Health Rankings data, and it's a spreadsheet, and then it's from the www.countyhealthrankings.org, a collaboration of the Robert Wood Johnson Foundation and the University of Wisconsin. I stumbled across it. Some of you may already be familiar with it. I thought it was interesting because the focus of this effort is to rank within state the health of individual counties. But if you're interested in doing more than that, you can look at some of the variables that they use. And it turns out if you go to their ranked measure data tab, I actually added a field in here, and there's the two reasons I'm talking to you about this. You'll hear about it in a sec. But you can see all these different, see, what do I do? Quit that. Yeah, so on my screen, my webinar window is obliterating my scroll button, so
You can press this little thing.
that thing there.
Yeah, and then it should get.
Thank you. So here are some of the variables that are in that. Some interesting ones. Percent fast food restaurants. Of all the restaurants in a county, what percentage of them are fast foods? Number of recreational facilities. No. Yeah. Percent of the population exposed to drinking water that's in violation of standards. Children in single-parent households. Wonder where they get that data, if you know census. Inadequate social support. Children in poverty, another census variable. Unemployment, another census variable. High school graduation, yet another one.
When you say census variable, are you distinguishing between census, decennial census, and American Community Survey?
No, it's simply a variable that they would have acquired from us. It could be a number of different sources within the different census products. I'm showing you this this table for a couple of reasons. One, to show you all the different variables that they put together, and then they assigned a ranking factor for each variable to come up with the health of the counties, and so you can compare your county in your state to all the other counties. But you can also take the individual variables and map them. That's what I did for the smoking variable. But I wanted to point out what I did to you here in order to map the thing. This row right here is not in the original data set. The nice thing about this data set is that, I'm going to stand over here a little bit, is that they included a FIPS code, state county code, join field. Whether they were doing that on purpose or not, I don't know. But once I saw that field, I thought, I can map it. And, but it had these field names up here. And if you've done any joining at all in ArcGIS, you know that it chokes pretty readily on anything that's not standard. And by that I mean you can't have field names in any external data source that you expect to bring into ArcGIS that start with a pound, for example, or have a blank that starts with an underscore, an asterisk. There's a whole slew of characters that if they're in your field name, your join will either fail or it will only work partially. And there have been times when I pulled out what little hair I have left, frustrated by trying to figure out what it was preventing the join with that data set. And then you find it, and it's a little apostrophe in one of the data fields somewhere. And it's just maddening. So I've come to understand over the years that I just take and add my own variable names, make a separate row, and that's what I did here. And then to do the join, if you didn't know this already, if you're taking a spreadsheet, you can't have these extra headers. To join a spreadsheet, you only, the very first row, which in a database is called a record, has to be the field names. Right, so in a spreadsheet, this field right here, I'm trying to make a long, I guess I could highlight it this way. Duh. The fifth field is the join field. And the third row is the header field. Not in this particular spreadsheet. This one just has the names in it. So what I did to actually join this table to the county layer in ArcGIS was created a new spreadsheet and where I stripped off those first two records. so that now I have some very neat and predictable field labels, although some of you can't tell what depth 1 and depth 2 are, but that's why I had the other spreadsheet open to differentiate between them. And unfortunately, that is the same practice you kind of have to do with census data. Because we have so many, literally thousands of variables, we can't possibly name them with their full names. First of all, you would be reading forever, and second of all, you'll never get them into the database. So everything's got some kind of ID, identifier. And so part of your challenge in doing the join itself is finding matching that ID, that field ID, with a description that makes sense to you. And we're going to get into that here. That was your Easter egg.
Is that a publicly available data set?
Yes, don't worry.
No, I was just asking, we can get it.
Yeah, and in fact, I showed you here. It tells you where to get it. All right. This very first tab, right here, www.countyhealthrankings.org.
And that's on the CD or on our website.
Yeah, the data are on the CD over there. It talks about the variables and the sources of the variables, so it's fairly well documented data. Okay, so let's talk about American Fact Finder. How many of you have used Fact Finder before? Could you show me your hands? Successfully downloaded data from Fact Finder? Okay, still many of you. Okay, that's good. So if you're comfortable with downloading data and you have a variable in mind, or I give you an idea, just go for it, do what you like. We're going to go through a few short exercises, and then we're going to pick a variable. I guess I'll go ahead. No, this takes forever to load, so I'm going to leave it run. Let's see where I am here. Here's Fact Finder. So let's start your American Fact Finder, and if you need help on where that is, start at the Census Bureau's home page, www.census.gov. Isn't it funny you don't hear people, what's the web address? People don't say the www anymore. They just say census.gov, or the whole www was World Wide Web, right? That definition meant you were supposed to use a web browser to get there. If you remember way back at the beginning, because there's also ftp.census.gov, and if you go there, it's our list of files that you can download from FTP. Anyway, under Data, there's American Fact Finder. Now, why am I not talking about other options? As I mentioned to you before, there is a data tool that you can, a macro that you can load into Excel. It works really nice at downloading variables, but your resulting product won't have a join field. You can go in FTP data yourself and pull down the raw data, but then you have to also download the templates for Access or Excel to load the data into the template. So in a nutshell, if you're looking to get data for more than just one county into your GIS, Fact Finder is the way to go. There may be one or two other simple ways of getting data in there, but really I've come to realize that Fact Finder is the best way to go, unless you're going to do a whole country's worth of blocks, in which case you've got to FTP. Unless it's pre-joined. We'll talk about all that. We could. So let's go to Fact Finder. And trust me on this, this session, if Jerry O'Donnell were here, my colleague who just retired, who knows the data inside and out, and is known nationally as the Fact Finder dude, I'm not going to give you a Fact Finder in and out. I'm not here to tell you about what all the neat things it does and how it'll make a map for you and how you could look up an address and look up your congressman. It does a lot of stuff. I'm not going to cover any of that. I'm assuming what you want to do is find a variable and get it and map it. So I apologize if you wanted to learn more about FactFinder. I'm not your guy. There are a lot of tutorials online that you can watch, little video clips that show you how to use FactFinder. They'll do other things. But our focus today is to get to a variable and bring it down to your desktop or laptop and use it. That said, you want to click on Advanced Search. Now, why, after clicking on Advanced Search, you still have to click on Show Me All, I don't know. It just would have made sense to simply not do that. But go ahead and do Show Me All until you have the screen that looks something like this. With a, how do you describe it? A step 1, 2, 3 thing. We're not going to use this step 1, 2, 3 because it's, in my opinion, it's a waste of time. Again, I'm worried about getting my data. I want to get it out, get on, and move on and do my mapping or analysis or whatever it might be. The thing about FactFinder is that it's not designed for geographers and GIS users. It's designed for the average Joe or Jane who's looking for data, and they don't really know much other than that. And that's fine. If you, gee, I'd like to understand the demographics of my hometown, FactFinder, you know, do a quick report. Works great. And what's the education level? You search that. Oh, great. Usually, if you're doing GIS analysis, you're not analyzing one place. How much analysis can you do? Why do you need a map if you're just going to map Helena's population? Usually, if you're doing GIS, you're doing some kind of an analysis. And usually, if you're doing analysis, you're doing multiple locations. You could be doing point location analysis. Most of the time, if you're going into GIS or census, you're looking at some sort of spatial analysis with census geographic areas. Almost everything I'm talking about today can be done as points. And there are times in GIS when you want to use point locations for your analyses rather than aerial definitions. I could probably think of a few examples if you give me a minute, but there have been times when I'll take block centroids, the center point of a block, rather than the polygon of the block to represent a distribution, for example. So I'm only mentioning that because it should be something that's in your mind. Do I want to look at this aerially or with dots represented on my map? Do I want to look at the shapes of the boundaries or what? So you do have that option. To get the points is a little bit tricky if you don't have them already, but you can create centroid representations on your map with every product that we create. Every data variable has embedded a latitude, longitude for that piece of geography in the data field, in the geographic header. We're going to see that here in a sec. So if you download information for American Indian reservations, you're like, okay, great. All these polygons, it's messy. For every variable that you bring down, there's a field way out there that has X and Y, and latitude and longitude for the centroid of that geographic area. And you should be aware of that. Back to the screen here. I find it best, all that said about points or areas, if you define your search first by geography. Now, that assumes you know what you're looking for. Sometimes we approach a problem and we don't really know what geography we want. And that's understandable, especially if you're not a census geographer. If that's your situation, if you find yourself in that situation, you need to think that way first, in my opinion, because the geography will determine what data you can get. I could say that the other way around. The data will determine what geography you can get. But since we're using GIS, the assumption here is we're doing geographic analysis. So as a geographer, I'm going to approach that problem from a geographic perspective. What are we doing? Well, today in our demonstration, our exercises, we're going to be looking at tracts for Montana. And that's a nice statistical geography that fits together like pieces to a puzzle. Let's think back for a little bit to that presentation earlier this afternoon about census geography. If I'm going to do a distribution analysis, if I'm going to do a change analysis, if I'm going to do any kind of analysis of census data that depends on the distribution of that or the location of that, I'm going to want to use, as a geographer, a piece of geography that's well distributed. And by definition, that's what a census tract is. I could use blocks. They're very well distributed. They're well defined. But what is it about blocks that's not going to work for me? And this is the part that I'm not touching on, which I probably should at least spend a few minutes on. The level of geography defines what data that you can get. The American Community Survey is a sample survey. Unlike the decennial census, where we asked every person for a response, it's not exactly true. If you're a kid, we didn't ask you for your answer. We asked your parents, or they filled out a form. But the result there is that we have a representation for each and every person in the country, for every household in the country. There's supposed to be a response from everyone. Incidentally, another plug, and I do this once a year, we at the Census Bureau, with support from the National Science Foundation and the National Academy of Sciences, to do a sample census in 2000. Why? Because the 1990 census was expensive, and we knew the 2000 census would be even more expensive, and we knew the 2010 census would be more expensive. And we knew, as statisticians, I'm not one of them, but we knew as an agency that we could do an accurate census based on a sample. Samples are done all of the time. Scientific samples are very useful, and they can be used for all kinds of things, including redistricting. When Congress said to census, gearing up for the 2000 census, you must reduce the cost of that darn census. You're spending way too much money. We came back with a proposal, and the proposal was to do a sample census. When that went to Congress and the two parties started looking into it and thinking, oh, well, that means maybe our party won't get counted as much as the other party. We can't have that. No. So we're going to fund you for a complete count. The Census Bureau had defined it, that's not the word I want. We had designed a sample census for 2000. We were getting ready to roll it out. It was going to be cheaper, more accurate. Congress said no. In 1999, January of 1999, they said, you must do a full count. And it went to the Supreme Court. And the Supreme Court upheld it, said, no, you must count everyone. So if you want to know why we do what we do, blame your congressman and the Supreme Court. What's in the Constitution is that we do a full enumeration, and the Census Bureau proves statistically we can do a full enumeration with a sample count. The Supreme Court disagreed. So they gave us another $2.5 billion and required that we go to every house in the country. Every house in the country. Think about that. Think about how big Montana is. What if your job is to drive every house in Lewis and Clark County? Not just some of them, all of them. You have to knock on every door, not some of them, all of them. That's why it costs so much to take the census. That's why we hired 350,000 people to do the census. And that's why you have error. That's why it takes so long to get the job done. I'm not saying it's good or bad. It's a challenge. It's a huge challenge. And every decennial, we go through this argument. You have the one side and you have the other side. The net result is that we counted everybody in the decennial census, and it costs a whole heck of a lot of money. The ACS is a sample. Now, if you use ACS, you know that at small levels of geography, the sample is not any good. It's a high margin of error. And therefore, in that case, you don't want to use some of that data. It's no good at small levels. So what level of geography are we talking about? It depends on what your variable is, but if you're talking about counts of people, and you need the official information about how many people there are, voting age, how many housing units there are, the only place to get that is from the decennial census. And you can get it for any level of geography because we counted everybody. If you want to know what types of home heating fuel are being used in Montana, we didn't ask that of everybody. We did it in the American Community Survey as a sample. So because we conducted it in a sample, and the sample was randomly selected, designed to be evenly distributed across the country, there are, by definition of random, there are going to be places where the sample wasn't large enough to produce a good result. So there are minimums established at the Census Bureau. By and large, the census tract is the level of geography for which almost all data is available. Now, some of those variables at the census tract level still have a very large margin of error because of that sample. Block group was originally the smallest level of geography and still is officially, but your margins of error for almost all variables at that level is so large that if you were to do an analysis, a serious analysis, a distribution analysis at the block group level, you're going to be making a grave error in your analysis. What is acceptable at the block group level is to use aggregations of block group level data into larger units. Custom defined aggregations for water districts, maybe fire districts. If you want to assemble occupation data at the block group level for a larger area based on aggregations of individual block groups, that's good. But saying this block group has a poverty level of this amount or has an education level of this amount and it needs federal funding because this one next door does not, you're really stretching the data far beyond what's intended. That's a very simple example of the problem. So, back to this issue of geography.
Before you do that,
yes.
The annual population estimate, which is that all done by modeling within census? Because that's the official numbers. All this ACS stuff are statistical.
That's like correct.
The population estimate, which needs some normalization from the census data anyway, is the official number. How does census get that? Is that the model?
The estimates are based off of the decennial benchmarks, and I can't tell you exactly how they do it, but you're right. The ACS are only estimates. No, we don't even call them estimates. We call them characteristics because we want to differentiate the data in the ACS from the population estimates program. So we refer to ACS data as characteristics. If you're looking for the official population, you're going to use the pop estimates. If you're looking for the most hardcore number, if you're trying to determine how many people were affected by this flood with these boundaries, you're not going to use the estimates or the ACS. You're going to use the census data, knowing that it's 2 or 3 or 4 or 5 years old because it's an actual count and it's at a small level of geography. If I'm doing an analysis of environmental impact, whether it's a hurricane, a flood, a tornado, a hailstorm, you're going to want, most of the times, fine-grained detail. And there you're talking census blocks, just like you would for redistricting. Whether you're doing districting for your schools, for the state, or a water district, you need fine-level detail. That's the purpose of the data at the block level. But you're not going to get income. It doesn't happen at the block level. And you can't get it before 1990. It doesn't exist. You can't get block level information before 1990. It's not there anywhere. So I get this question a lot. Well, I'm looking at the 2000 block level data for Chaffee County, and I want to see what the distribution was in 1940 before World War II. You know, maybe one of the insurance companies put that down on one of their rate maps, but we don't have it. So what level of geography are you after? Today we're going to talk about tracts. Tracts do a great job. There are no gaps and no overlaps anywhere in the country. That's what topology is all about in Tiger. We ensure that. Same is true for block groups and blocks. So if you're talking about a tract, you know it does not overlap any other tract. I guarantee you it doesn't. If you're going to do all tracts in Montana, you will not have one iota of a hole or overlap. It's every square inch of the state is covered. There's perfect alignment. And that's the great thing about the statistical geographies, the tracts, the block groups, and the blocks. If I'm going to do income or occupation analysis, I can get a lot of that at the block group level data. But once again, that's so small, that sample is too small. The data margin of error is going to be too large. We don't want it. And we're going to talk about that at the end. Maybe I should talk about it up front, but I should not have let it do this because now I'm going to regret it. Yeah. Are there any questions about those minutiae of geography? As boring as all get out, right? Okay, without saying a whole lot more about that level of geography, I can be pretty safe to assume that almost any variable I'm after will be available at the tract level or higher. Just about any data item I want is at the tract level. Some of it is suppressed, and you'd be surprised how much of it is suppressed because of that error again. County level, just about everything, but there are counties in this country with only 375 people living in them. And if the sample in that county was small enough, there's going to be data that was not released because of the small sample. And that's the reason for the 1, 3, and 5-year ACS data. And again, I'm not talking a lot about the ACS, but that term defines the survey window at which point the data are aggregated into a product for you to use. While the ACS survey itself is conducted every month, the data are aggregated for a single year into the ACS 1-year data. They're only released to those entities that have 65,000 or more population because of that sample size. The 3-year data goes down, I think, to 20,000. Some of you might know better. So after 3 years of sampling in those geographies, there's enough confidence in the data that we can release it for that frame. For smaller levels still, we only come back often enough, or not so often enough, that we can release it as a 5-year sample. So how does that work if we release 5-year data every year? Normally I would draw something. Last time I drew it over there, but I'm going to picture it instead. Honestly, you don't need to worry about it. I'm going to use this little block up here on the screen. And if there's somebody out there in network land that's not seeing me, I apologize, but I'm pointing now to the fact finder screen. And we've got this little tan block in the middle of the window. Imagine that block divided up into 5 chunks, representing the 5 survey years of the 5-year ACS data. And right now you can pull down 2007, 2011, each one of those years there. Next year, when they release the 2008, 2012, you can think of it as that frame being moved 1 block to the right, not 1 tan block, but if I've divided this, subdivided 5 times, move it 1/5 to the right and take another sample of that time frame. And then release that data chunk as the 2008, 2012 ACS 5-year. Next year, we do the same thing. We move that reference frame 1 year to the right, but we're still collecting 5 years worth of data for that piece of geography. The data are published for the last year, the geography of that last year. As you know, geography changes. If you're using census tracts, you're relatively safe because they don't change, but if you're using places, and some people might, they change. What geography? If you're collecting 5 years of data, and I've had 5 years of annexations, what? The data, when they're released, are all published based on the geography from the last year of the sample taken. And that has a whole slew of other ramifications that I won't get into today. If you've got large changes in your geography, in your analysis window, then you might not be doing the right kind of analysis. Okay, back to this American Fact Finder chart. Hopefully I've laid a little bit of groundwork about what it is you should be looking at and what you might be looking for. The easiest thing for me is to identify my geography first. I know I want to do an analysis of homes in Montana at the tract level because I'm very confident of that distribution and of the accuracy of the data. So on the left side here, I have a number of boxes I can choose from: topics, geographies, race and ethnic groups, industry codes, EEO codes. I'm going to choose geography. So I'm not even keying anything under option 1 in the main window area. I'm leaving that alone. And I'm going to wait for it because FactFinder is so screamingly fast. And as I proceed, I want to make sure that this little radio button there, which says all geographic types, is clicked, turned on, or else I won't get all options presented to me. I don't know why they decided they should give you a reduced selection set otherwise, but I want to make sure when I choose my piece of geography, I have all options available to me. Now, what you're going to be presented with from this point forward is based on the hierarchy of geography. So now when I go, I can certainly search within this list, but I'm not going to do that because I want to show you the drop-down. This drop-down that appears when I click on the button there is that geographic hierarchy. United States at the top. Notice the little 3-digit code over to the right. That's not a FIPS code. That's a census summary level. And if you're an experienced user of our statistics, the term summary level should be familiar to you. Every level of geography at census has a code identifying its summary level. If you're a regular user of Census Tracts, you'll know it's summary level 140. You don't have to know that because you can look for it. You will see it listed more than once, though. Like in this first, I'm looking down at where it goes United States Region Division State. State is 040, great. Then I see county, county subdivision, place, census tract. Oh, there's Census Tract. There's my piece of geography. You don't want that one. Why? Because this is the hierarchy underneath county subdivision. Tracts are split by county subdivisions. Remember, tracts are statistical entities. They're defined without regard to political units. Blocks are defined by both statistical and political units. Census tracts are not. So if I were to choose this one, I would get a record for every piece of census tract split by a minor civil division. I don't want that. That's messy. I could deal with it, but I don't want to deal with it. What I want is a pure record, a record for pure census tracts. And if I scroll down here, aha, census tract. I clicked on it. I didn't mean, I wanted to highlight it, but I ended up clicking. So this, essentially what I've just done is selected a geography that started at state, went to county, and then tract. So there's no intervening geographies. I'm talking purely statistical geographies at this point. I know that the summary level code for tracts only is 140, and that's something you can remember if you choose. It could be helpful in the future. Block groups are some other code I don't remember off the top of my head, but whatever level you choose, that could be a useful thing to remember. Okay, once it looks up this code in the geographic tables, it's going to let you start to winnow down your choices. And I really find this process the easiest thing for me to get me the data I need for the geographies I'm working with. Remember, I said before I wanted to look at home heating in Montana at the tract level. Now, it's probably a little presumptuous to assume that everybody has that detailed thought in their mind. We could go through other exercises to get us to that point, but for demonstration purposes, that's my assumption at the moment. All right, I'm selecting Montana as the state. And once again, it's churning its little wheels there. What it's doing is looking up all of the geographies at the tract level within Montana in the lookup table. And it's asking me to select a county. This is the beauty of the tract and actually FactFinder. They were kind of looking out for us some here in the sense that I could choose a county and then pick the tracts within that county, but I already told you I wanted to do the whole state. So I'm going to skip this select the county option and go straight here to select one or more geographic areas and click add to your selection. That's an important little detail there. You click on all census tracts within Montana, highlight it, and then you must click add to your selections. Now something's going to happen when you do that. I'm going to show you after it finishes processing. What it's going to do is add this piece of geography to your search criteria, which is this upper left block where it says your selection in the upper left. Search using, and right now it says census tract, all census tracts within Montana. So now everything I do in FactFinder is now going to be defined at a minimum by that piece of criteria. I can add more criteria, and we will, but it's not going to give me anything outside of this geographic definition. That's cool. That's what I want. So I am done. If you don't pay attention, this is very easy. You will forget that this box is still here, and it'll prevent you, the select geographies box, it'll prevent you from doing anything else until you close it. So you have to close that in the upper right corner and get it out of your way. And lo and behold, underneath there are a whole bunch of variables that are available at the tract level in Montana. In fact, it's every variable that's available to you at the tract level in Montana. Holy cow, there's a whole bunch of them. Now that that's done, I can choose topics. I just clicked on this bar over here on the left above geographies. I clicked on topics, and I'm already at topics, so that was a silly thing to do. I can refine my search. Now I'm over here, and we've got two boxes in this tan area at the top of the list here. I can search by topic or table name. Now, I don't know the table name. All I know is I want something about home heating. Now, the minute I typed in heating, a little pop-up window popped up, and it said, here are all of the variables that have anything to do with heating. And these are from all of the different data sources that FactFinder has stored. I happen to want the variable B25040, house heating fuel. I'm going to choose that. Click on it. Nothing happens. I must have to press go. Okay, that was pretty quick. So now it leaves me with a little table there on the screen with 4 options. All 4 say house heating fuel, but there's a difference. So what we've got, if you look on the data set field over here halfway to the right in this table, you see we have the very bottom record reads 2009 ACS 5-year estimates. Right above that is 2010 ACS 5-year selected population tables. Now, I have no idea why that's there, but I know I don't want it. Right above that is 2010 ACS 5-year estimates. Yeah, it looks a lot like the 2009 one, so maybe that's what I want. Well, it would be, except I want the latest information that's available. The latest information that is available are the 2011 ACS 5-year estimates. So I'm going to click the little checkbox. I am now ready to get my data. you can do one of two things. I can view it, and it'll bring up a table, which will only show you part of it because there's so many counties and so many tracts, or so many tracts and a few dozen variables there that it won't all fit on the screen. And I guess I'll go ahead and do that. Let's look at it. So it's going to present me with this table, and it is actually useful in clicking on that because you can see what you don't always know is what the details are of that general category. I said house heating. Well, now you find out, well, there are several different types. There's utility gas, there's bottled, tank, LP gas, there's electricity, fuel oil, kerosene, coal, or coke, wood, solar, any other fuel, no fuel used. That's crazy. I wonder what happens in that house. I don't know.
Could be Hawaii. They don't use a lot of heating fuel.
Yeah, could be. Could be. Anyway, across the top, you see Census Tract 1, Beaverhead County, Montana. Next to that, Census Tract 2, Beaverhead County, Montana. Oh, guess what's showing up here? How convenient. Underneath this main header of Census Tract 1, Beaverhead County, Montana, Beaverhead being alphabetically the first county in the state, we see estimate, and then right to the right of that, margin of error. The margin of error is always a number in the same units as the estimate. It's not a percentage. It's a total number, so that you see margin of error. The very first record here says total. So total estimate in Tract 1, Beaverhead County, Montana, is 699. That's the estimate. The margin of error is plus or minus 73. That's it. That's 73 houses. And this is 699 houses. Anytime this margin of error gets larger than 15% of the total value, you're in the danger zone. You should be very cautious about using that data. What this means, basically, is this value could be 699, or it could be 772, or it could be 620, what is that, 26? So it's somewhere in that range. That's what that margin of error is about. And we don't give you the option. You get the margin of error. When you order the variable, you're going to get the MO, as we call it, M-O-E. It's 90. I don't remember if it's 95 or 99%. I don't remember. I have a slide demonstration at the end, and it might tell us in the confidence interval. I don't know.
Are you concerned? You're concerned with the margin of error for any of those numbers, but you start with the total, and if the margin of error was outside of 15%, you wouldn't use anything in that column. But if, you have to think about using stuff in the column. But if you went to one of the variables in that column and found that one was outside of 15%, you would just simply not use that.
That would be my choice, yes.
Okay. You can use the rest of it. But
Right. The thing about tracts, though, one thing that would trouble me about that is that tracts are supposed to be defined as homogeneous units. They're supposed to be the same size in population. That doesn't mean the sample was the same size. And so in a perfect world, we would have sampled every tract at exactly the same rate. But that doesn't happen, even in a random world. With a 5-year window, it's not going to happen. So there's going to be some variability in there, whether we sampled each tract the same amount. So that will happen. If you get to the point with any particular variable where a large percentage of the tracts have a large MOE, then I would start to question the entire data set and say, maybe I shouldn't be doing this analysis at all because too many of the tracts have a large margin of error. But in this case, it's not true, or at least in this part. You start to look, some of these individual ones, like coal or coke, there's an estimate is 0 and the margin of error is 78. What does that mean? Well, you've reached the limit of my statistical ability, statistical ability here. As a geographer, I have no clue what the ramifications of those within variable differences are. This way or that way? Yes, right here. Okay. And let's see what we got there. Oh, there's a pop. I was afraid it was going to take away my, you know how that can be. Oh, there we go. 90% probability of the interval defined by the estimate minus the margin of error. So it's not 95 or 90, it's 90. Let's go another 15 minutes and have another break, okay? Is that all right with everybody? I am getting even it out here a little bit. At this point, I can download the data for the whole data set, and I'm going to do that. Even though I'm only showing a piece of the table, if I choose up here where it says Actions near the top of the window, Modify Table, Bookmark, Print, Download, Create a Map, you can create a map, and it's not a bad one. But hey, we're geographers. We're running GIS. We're not going to use no stinking create a map. We're making real map here. We're going to download the data. So I'm going to click on Download, and let's pause at this window for a moment. The pop-up window is going to give you some options. It changes all the time. When it first came up, you had different options than this, but this is actually simpler than it used to be. You have two general options here for your download. Basically, it's asking you, do you want to present this as a nice, pretty-to-read chart or table, or do you want to use the data in some kind of analysis? Obviously, we're going to do some kind of analysis, so that limits us to a comma-delimited format file. And you can choose data and annotations in a single file or data and annotations in a separate file. Now, if you've done it, you can do it either way, and either way it works. I'm comfortable doing it with this first box checked and leaving the descriptions out. If you choose the descriptions, you get a separate file that lists what the variables are. I approach it differently, and I'll show you that option. You can click that if you like, and it'll give you the list of variables and the names along with it. I'm just going to leave it blank, and I'm going to say OK. And I kind of would have expected to actually download the thing, but it basically was doing some back-end processing and says, OK, it's done now, you can download it. So I now click on Download, and it's going to ask me to save the file. I'm going to go ahead and open it right away with WinZip. I don't know what you guys have installed, but I assume your file handler will do something similar. There is Windows does have an unzip utility built into the OS, so if you save it and go to your desktop and double-click it, it should extract it for you. If it doesn't, you're still okay because we did this already and we've got the files on your hard disk. The reason I wanted to show you this is that these are the files that you get. And I'm going to open this one. Even though it said I didn't want the descriptions, it gave it to me anyway. No, I did not. I got the wrong one here. It gave me this metadata file, and it tells you, here's the field variable name, and here's the description. And you'll notice for every variable, we have a margin of error. So you even have a margin of error for the total, as we saw on the table. So here's the estimate, HD01_VD01. That's the estimate for this piece of geography. And then right after that is the margin of error for that same piece of geography. So I don't know why you might want that other option, but the data itself are in this first one I clicked on. There's a README here, and then there's a little bit of text file about the variable you downloaded, the house heating fuel. Then this is important right here. Anytime you do an analysis of a census data variable, whether it be an ACS variable or a census 2010 variable for 100% count, you have to be cognizant of what your universe is. And let me spend a moment to define that for a sec. You see here it says, I opened that text file, if you weren't following. There's a text file that was part of that zip package, and it was called AFF download readme _and.txt. And inside that file is a little verbiage about this particular variable. I'm not sure it says anything about the universe. Sometimes you find helpful stuff in these things, other times you don't. But what I wanted to talk about was this universe, occupied housing units. That means that this count, this number, didn't take into consideration all of the housing units. Wait, what do I mean by that? Okay, imagine, if you will, a place in Montana with seasonal dwellings, whether it be a location known for hunting and fishing, or maybe a ski town with seasonal units. Now for ACS, we go every month, so that's not as big of a deal in that situation, but it's conceivable that half of the year those housing units are vacant because it's a seasonal home, it's a second home, it's a hunting cabin, what have you. That means it wasn't in the universe of the count, because there was no one home to answer how it was needed. I mean, if you're just counting housing units, you don't need anybody home to say, oh, there's a housing unit. Yes, I have a housing unit. No. For home heating fuel, we have to do an interview to figure it out. So if there's no one home, we can't do an interview. Incidentally, we do go back several times to these homes trying to get an interview. And if you've ever been in an ACS, and I hope you don't, I have, it gets a little tedious. Even as a census worker, you're like, okay, come in. Ask you those questions again every month. How many months am I in this darn survey, you know? It is, I understand the frustration our respondents have, because it is a little bit burdensome. But to get some of these answers, it has to be an in-person interview. Now, I should say ACS has an online option now. And if you are selected in the sample for American Community Survey, that's your first option. If you don't respond, then they try to call you first, and they get you on the phone, and they'll try to take your survey over the phone. And if you don't do that, then we send people to your door. Some people say you're like, you know, the secret police or something, and you know, some people don't like it, and there's not much we can do about that. We're trying to get the best data possible, and sometimes our staff go a little overboard with that. But yes. Correct. That is a good question, and if give me a moment for the cogs in here to turn a bit, I might have an answer for you. The sample for the ACS is derived from the decennial housing list. So we have, it's not an independent sample, it's a dependent sample, and I believe from that we have a flag whether or not it's a seasonal unit. But that could change, so that's not possible. I don't know. I could look into it for you. If you would like to remind me afterward, give me a contact name and I'll get back to you. So this applies to almost every variable you go after. pay attention to what the universe is. It's going to tell you somewhere. Every time you go in and grab a variable, it's going to list the universe somewhere in the header or in the documentation. Be aware of your universe and make sure if you're normalizing the data, and what do I mean by normalizing the data? You know, as a statistician, that sounds all fancy schmancy. You're dividing by the universe to get a percentage. So if I divide, let's go back to this table for a minute. Mouse is way too sensitive. If it's the total. I'm sorry. So the total estimate for Census Tract 1 in Beaverhead County, Montana, is $6.99. If I wanted to come up with, if I were to normalize the utility gas aspect of it, I would do this as a ratio. I would divide the utility gas by $6.99 to come up with a percentage of housing units where that use utility gas as their heating fuel. Where I would be making a mistake is if I took this number 34 and instead of dividing it by $6.99, I divided it by the total housing units in Tract 1, Beaverhead County, which I can obtain from a lot of different sources. I'm not using the same universe. It went away. Oh, it says here. I'm creating a false piece of information if I'm not taking and using the same data from the same universe.
So that total would be the same number of occupied housing units as would be on a different report.
From the same survey, it should be the same number. It will not be the same number for the for the 3-year data. It will not be the same number for the 2006-2010 ACS data. Only for this survey, it should be. If you go find occupied housing units in another place from the same data, it should be the same number. That's right. That's right. That's correct. All right. So I did the download, and I got a zip file. I got those 3 files. I'm going to close my web browser because I don't need it anymore. And I'm going to go to where the data were downloaded. And that's going to be different between you and me. Where did I put it? I think I put it in here. Yes. So I actually did it for I did 3 different windows of 5-year data. I did the 2009 to 2011. I did the, you get the picture, the 9, 10, and the 11 5-year window data. And so I've got the metadata and that table data for each of those 5 windows. I was going to do a comparison. I never got around to it. But for today, let's look at the latest data, and that should be this one. And just by double-clicking it, because Excel is configured to load a comma-separated values file directly without doing anything, I should be able to double-click and get that file to open. So CSV stands for comma-separated values. It's a text file, meaning you can read it in a word processor, WordPad, or any other text document, text editor. It's got commas separating the data from each other. And any CSV file, as we say, has a header. And the header is the first record. So the header contains the field names for each of the fields to follow. If you were to open a CSV file, you can have a CSV file without a header. You don't need a header. But if you're to do it, try to do it in ArcGIS, it wouldn't know anything about what the join field was. I think it'll let you do it, but it names the first data item as the field name, and you get in trouble. So if you're going to use a CSV file, a comma-separated values file, as a joined table into ArcGIS, the very first row has to contain the names of each of these columns. And the fields have to be normal. They can't be crazy, or you're going to mess things up. It just so happens the way Census names fields in all of our data products is very compatible with the spreadsheet and with ArcGIS. It's just not very easy to understand as a human being. I mean, if you speak computer, this is great. Here is that text label where you will see, Leslie was mentioning before. So here's that link field. See it right here? It's geo.id2. By the way, that dot's going to be a problem for you. We'll get to that in a second. This other GID is I don't know, it wasn't a geographer who came up with this field, but the very first column labeled A here, geo.id, we'll have no use for that. It won't help us at all for anything. You can ignore it. It's the second one, the geo.id2, that we're going to use to create the join with. Column C is the label. And you can see here it actually says Census Tract 1, Beaverhead County, Montana. So this string just to the left of it is the digital representation of that tract, 30001, 0001, 00. And you'll see that this field, or this column, is exactly the same width all the way down to the end. So there's no deviation from there. Your actual values for your variables are over here, and they're labeled in a cryptic fashion as well, which is why you need that annotation file to tell you what they mean. Now, I understand with the geodatabase, you can create field descriptors as aliases that are somewhat lengthy and are a lot more helpful, but I don't have time for that. Usually I'm after one or two variables, and usually I pull it out and I give it my own name that I understand later. For today's purposes, we're just going to leave those census cryptic headers in there, and we'll decipher what they are using that little file that they sent along with us. But before we can proceed, we've got to change this file because ArcGIS cannot use it like this. So what are the reasons why? I pointed out really the only one, but it occurs more than once. These periods in the field names are going to create problems, so we've got to get rid of them. So rename these. Doesn't matter what you name them. Doesn't matter at all, as long as you know that this field right here is the one that's going to be your link field. You could come up here and literally just type the word link in there. And then get rid of A altogether. The column A, highlight it, right-click, say delete. We don't want that thing. And then this thing here, geo.display-label, why didn't they just call it label? How hard is that? I don't know. The rest of it's fine. So we could save it back as a CSV because ArcGIS will read a CSV just fine. But since we've already done the work in laying it out, I'm going to save it as an XLS or an XLSX. Doesn't matter which one. And I'm going to save it in a folder where I know I can get to it. And I'm going to give it a name that makes more sense, something other than ACS_11_5 year, blah, 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 blah. That makes
sense. If you guys are saving it, please save it in that folder on your desktop.
And let's see, I think I want it here, yes. So I'm going to change the type. I'm going to leave it as a workbook, and I'm going to call it Montana_heating. Say save. Let's take a break, and we'll continue with the actual join and do some mapping when we get back. Let's do where we left it was that we reformatted our data, the downloaded data at the tract level, home heating fuel, house heating fuel. The next thing we need for this picture are the census tracts, and you could acquire those in a number of ways, but I prefer that you grab them off that empty data folder that Leslie mentioned to you. So I have my own layer somewhere on here that I'm going to find of Montana tracts. So I'm getting rid of that Easter egg thing we had from before, and I'm just going to add, I'm going to find my Montana tracts wherever they are. There they are. So I downloaded the shapefile from the state of Montana, and you probably have the same one. You should, TL_2013_30_tract.shape. There aren't a terrible number of tracts in the whole state of Montana, so shapefile is acceptable. You could also open this geodatabase, TLGDB, and it's got tracts in it as well. So take your choice. I'm going to your pick. I'm going to choose the shapefile and add it. And once you have your tracts shown, let's see what we've got here. So there are only 271 tracts in all of Montana. That's not a whole bunch. We can deal with that. And you remember before I mentioned that every piece of geography has a centroid coordinate. That's what these columns are in the attribute table of the tracts. So you could literally save this attribute table as a table, as a text file, and then open it, add it to the sheet, and then plot XY. You could literally create a shapefile or a point layer out of it. If you wanted to do your representations as a scaled symbol, for example, rather than have shaded polygons. We're going to do a choropleth map this afternoon, choropleth meaning a color-shaded map. If I wanted to do a scaled symbol, I might choose centroids. You can represent maps. The beauty of GIS, of course, are the different ways you can represent the same information using various techniques. We're going to stick to the simple stuff here and do some shaded areas and create a choropleth map at the tract level. So there are 271 tracts in the state. That's the table. There's the centroids, internal point latitude and longitudes. Here are the tracts, and these are not generalized. That means every bit of detail that was ever collected at the tract is included in this shapefile. It's not generalized by any means. Let me open that attribute table one more time. Where is our link field in this table? That's not a rhetorical question. Who's got the answer? Which field should we use to link to the tract layer that we downloaded? Correct, GeoID. Now, I didn't name it that, but I think my presence at the Bureau had something to do with it. In the old days, they didn't have this field, and you had to create it in the old Tiger Line days. So after a bunch of cajoling, we convinced the folks who created the shapefiles to actually create this link field, because this is not part of Tiger GeoID. What they've done is concatenate, as we've talked about, the state, county, and tract code into one string. And you can see a perfect example of the written form of the tract right next to it, the name 2.02, or the long name version, Census Tract 2.02. So that illustrates that numbering and data storage scheme we talked about earlier. Now, you don't have to add your data table to the map in order to do a join, but I have found from experience that it works better if you do that. So I'm going to go find that that spreadsheet I created. Here it is. And I'm going to add that to my project. And because spreadsheets can have multiple pages to them, it asks you which one you're going to add. I only have the one. And once I do that, it becomes part of the map. I should be able to open it by right-clicking in the table of contents. Click Open, and it should open up just fine and show us the table. Now, I was telling Leslie I did a little something behind the scenes here while you all were on break. I edited the spreadsheet in Excel, and I renamed that one field. I called it Link. Some of you saw me do that. And then I went into the annotations file that came down with that zip, and I looked up what the codes were for a few of these variables. So here's that total field, and this was the margin of error for that total, but I'm not going to use that. I identified those, the field that was for gas and the gas mow, margin of error. And then I picked out wood, the wood mow, and then solar. And we know this is solar mow, but so I've got those named that way so that when I go to do the map, I don't have to. What are they? So it's ready to be joined. So I'm going to. You can actually do bidirectional join. You can go one way to the other, but I found this joining from the geography to the table works most frequently better. So you can do your spatial join here, but we're not doing a spatial join. We're just doing a straight attribute join. And so I'm going to choose the field from the shapefile that is going to join to, and that was the GeoID, if you recall. Since the table has been added to the table of contents in ArcGIS, it knows which spreadsheet I want to join to, but it does not know which is the join field. And unfortunately, I have a problem, don't I? Bummer. See that? What happened? I should have seen this coming. It only shows the label. Why? It treated him. So this is so frustrating, but it's good that it happened. So the link field in the shapefile, the GeoID, is a text field. You can join two fields together as long as they're of the same type. Whether I liked it or not, when I imported that CSV file into Excel, Excel saw numbers in there and treated them as numbers, even though it should have been held as text. So I can change that spreadsheet. Hopefully. I've had trouble doing that too. I'm going to have to cancel, and I'm going to have to drop this puppy because it won't let me do it while it's on there. So let's see if I can get in there and change that field to text type. Because if my join field in my shapefile or geodatabase is text, then the join field in my attribute table must also be text. So here's the other thing about, I got to close the whole thing.
Or just open up a blank one.
That's true. It drops it.
Really?
Uh-huh. We don't have to close our map, you just have to pull it.
Just
Technically,
just like slapping it.
yeah, exactly. That's what I really want to do. Wait, stop that. So I need to change this to a text. And how do I do that? Now, let's see. This has not worked for me in the past. But it did this time. Hello.
And it kicked it all over.
Yeah. I swear to you, there have been so many times in my career when I went to change the field to text, it wouldn't do it, and I'm not sure why. Sometimes it does, and sometimes it doesn't. Maybe it has to do with the top field. Who knows? But Diane in the front here pointed out that when I did, everything shifted to the left, which tells you in Excel that Excel's treating it as text. If you'll notice, anything that's text sits left justified. Anything that's numeric sits right justified. So now I got to save it again. And I'm assuming now that that act, simple act, created a numeric field there. Or no, a text field, sorry.
That's when you break out your smudge.
I don't know if you believe that or not.
I don't believe it.
Thank you, Sean. You said over to joining me, you
Okay. The act of joining in the GIS, okay, I'm going to do it just again. So the first thing I'm going to do is bring my tracts in there. So as I mentioned before, you could use the geodatabase right here, right above it, because it's got tracts in it, but I'm making it as simple as possible. I'm opening just the TL_2013-30 tract shapefile. It's tracks for all of Montana. So you get that on your screen first. Once it's there, you can now join that layer to something. And you can join it to a file that's not in your table of contents, but I prefer to add it because it simplifies the process. So I'm going to add data, just like I would add a shapefile, but this time instead of adding a shapefile, I'm adding a spreadsheet. And fortunately, it recognizes Excel spreadsheets. Another nice little fun thing that I should mention, with 10.1, ArcGIS Desktop no longer lets you join to MDBs. So where I used to be able to use Access databases to join, now you have to use the JET ODBC drivers to make. That's just crazy. So another reason why I went to spreadsheets. You know, if I knew more about why and where, we'd talk about it, but it doesn't matter. So I'm going to add the spreadsheet of the house heating fuel to, oh, I got to choose the page. So now I have, on the top, I have the table of contents window. I show the tract shapefile, and then right under that is the listing for the actual home heating fuel spreadsheet. And I'm going to open it again just to have a look inside there to see. And it looks like it says it's text. You can.
Actually, right click on it and check properties. I wonder if you can do it that way.
Hello. Says it's string,
Okay.
so we should be good. So now when I say, I'm going to go to the layer that I'm going to join from, so I'm going to go to Tracts, I'm going to highlight it, and then I'm going to right-click on it. Or you can either double-click it. You can just go click, click, and it opens. No, that's not what I'm sorry. You got to right-click, or it's getting late. You got to right-click on it, and then choose the join option. There is another menu option, but I'm not going to worry about it. I've got a message here that we're experiencing difficulties, so I don't know if that's any of you. And I'm going to choose join. We did lose connection.
Okay. I'm going to make me the presenter, then give it back to you because that's what worked last.
Okay. So I'm gonna take a few steps back here, and I'll wait for Leslie to. Yeah, I'm disconnected. Now
let's go back.
It actually says I'm showing screen.
Okay. Did you get a message saying show screen?
Yet, then you can follow along. If you are, you can choose to do what you like. So, my link field in the shapefile was the GeoID, and lo and behold, my link field shows up in my spreadsheet. And I'm actually going to do a validate of the join. And it says I've matched 271 of the records, which is a good thing because that's how many tracks there are. And I'm going to say OK. So one way you can verify that it actually worked before doing any mapping is you can do an identify. It's one way to do it. Click on one of the polygons and scroll down and make sure you have values in the fields that are labeled. And I do. So let's map now the one of these variables. And to do a corplefic, you do a right click or a double click. You go to properties. This is the weird thing about Esri software. I mean, why do you click on the layer to map it? I suppose it makes some kind of sense. But under Symbology tab, under Layer Properties, these options here are based on, if you didn't already know, the type of field value that you're going to map. You can do a categories for any field that is non-numeric. So if you have all roads that are green, for example, you could create a map showing green roads. Any value that's repeatable in a text field you can do by categories. If you're going to do quantities or charts, you need numeric values to map. And I'm going to do, is that what I wanted to do? Yeah, it was. I'm going to choose graduated colors, and I'm going to do wood, because I just like wood-fired stoves and cabins and whatnot. Now, this is the total number, and I can map that. And it's somewhat useful if you're interested in your, let's say I market wood stoves, wood home heating stoves, and I want to know what my potential market is. I might want to look at the total number, which is now what is being shown in my, I haven't done anything the software chose these breakpoints and the color scheme and everything, and I can go ahead and map it. And it's going to show me the total number of wood-heated houses that are in that universe that we talked about, occupied housing units. And that's, you know, moderately interesting. There's a pattern. There's obviously a geographic pattern to the result, which you would never know about unless you mapped it. That's the whole attraction to GIS. But what if I was interested in market penetration for my product? So this is great. It's the total number of wood-fired, wood-heated homes, but maybe I should normalize the data. Why would I normalize the data? So I get a percentage of homes that are heated by wood, and that might tell a different story. So if I go back in here and I normalize the wood by the total, and I know I'm using the right universe here because it's from the same table, all of a sudden I get a different picture. Now I'm going to fix these labels a little bit. And these are a percentage, but the number represents fraction, and blah, blah, blah. The map would look the same. I'm just playing around with the numbers here. So it looks like there are some tracts where up to 50% of the homes, the map doesn't look a whole lot different. That's a lot of homes, a large percentage of homes being heated by wood. I'm surprised, maybe you all aren't. Not surprising, however, is the fact that the urban areas are not.
You just need to overlay the national forest.
It would, which one could do using GIS. Let's do something a little different. Let's have a look at solar. Now notice I didn't have to change the normalization. We're still normalizing by the same variable. But look over here. Holy cow, not nearly as many, but that could be expected. I mean, maybe if I were creating a creative map here, I would choose a yellow shading scheme. Oops. Oops, 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 oops. I don't know. Maybe no. Maybe orange will have to do. So there's some tracts with a higher percentage. Well, that's interesting, but how reliable is that data? How can we determine that? What if we divide the solar by the solar MO? What does that tell us? So the margin of error is, yeah, so, but I actually did it wrong. I wanted to divide the MO by the solar, don't I? To get a percentage to see, let's do that. So there's the solar MO, margin of error divided by solar. Holy cow. They're all within a there's such a small enough range that it only gave me 1. That's not very helpful. Let's force it and see how widely distributed that is. Something funny is going on. What is it?
The other ones are no data?
Let's look. Let's find out what's going on. There's solar. Yep, there's 0. Divide by 0, you get nothing. So the MO is still, except here's a situation where the MO is actually 9 and the solar is 6. So what can we say about that map I just made based on the margin of error and the prevalence of 0 values? It's not a very good map to make. The data are not very reliable for this variable. So basically, I have to toss out this entire variable for this. There's a term for this. It's a variable for the subject matter of home heating. Solar is not because of the small number and the high margin of error, mapping solar under this variable is not reliable. Is that true of all the other variables or just solar? So we can tell which ones the MO are because they're the HD2. Anything with HD2 is the margin of error. So, well, let's look at the wood margin of error. Here it's huge for this first record. Look at it. It's half. It's 50%. It's more. It's 60%. Here it's 60%. Here it's not. Here it's around 15%. That's about right. Here it's huge. So I'm beginning to think that maybe there isn't a variable in this whole sheet that's reliable due to the amount of error in the data. I don't know. We'd have to look at each one individually. Gas looks pretty reliable. Look at gas. The margin of error for most of the tracts seems pretty good. Why would that be? Why would gas have a more reliable indication of the total number be more reliable for gas than for wood? The sample is the same. We're going to all the housing units asking that question. Why is the result for gas more reliable than for wood or solar? No, the answer here has to do with the percentage of homes of the total that are gas. So much larger number of homes are heated by gas and therefore much larger sample for gas. So the data for gas is more reliable.
And this sampling that went on, you could have a house that's heated by gas and wood. I wonder how that might mess up these numbers. They took a prevalence. They said, what's the majority of your heat?
Yeah, when they asked that question, they could only give one answer. So they would have asked, which is it? Which is the primary heating? And they would have done it that way. But if you're doing a sample throughout the county, and the vast majority of houses are the tract, the vast majority of houses are heated by gas, and your sample is random, you're going to hit more of those gas. You're going to build up a statistical sample for gas that's more reliable than you will for solar. So in this case, I think if we map the gas, let's do that.
Then we're not talking about data that really varies by geography. It's not going to change that much.
Let's first do gas by total. And yeah, you can start to see now why. And I'm not going to put it in percentage. We're all smart enough to see. Maybe I should have done a different breakdown, but there's some tracts in there with some huge gas, and not surprisingly, huge percentages of gas. We're looking more at the urban areas, where I'm guessing you have a central gas supply. And of course, we could click on some of these and find out exactly what the answer is. Based on the characteristic, right? Nothing's exact. I said exact, but that would be wrong. So the total universe of sampled houses here is 1470, and gas, it's 1169. So the gas mo is pretty low. It's about just over 10%, so 13%. That's acceptable. So I think it would be reasonable to make a map showing the prevalence of gas-heated homes using this variable, but some of those others, I don't know. So we're going to move on with another presentation, but before I do that, so I move from mapping into the presentation on error, which I don't understand much of, so I'm going to skip through a lot of it. Are there
you guys have questions?
Are there questions?
Just ask Joe.
There you go.
Yeah, he'll be happy to talk.
Are there questions about what we've done so far? About the join in particular?
What might be useful is to look like this big data, the cadastral data, and the data digging stuff. So it's by household. And it's relevant to that category.
That would be interesting.
It's interesting because how what to rate this data versus what the assessor said about people how you think about rural Montana and how often assessors rate, through time they can sort of tell, well, maybe they can tell really any time, but it's probably a little bit less reliable. But one thing you can do, if you wanted to go to the finer level, would be to look, for instance, at this gas heating, compare that to the cadastral for that same tract. You get a little idea, because this is more timely data, theoretically, than every 6 years of the cadastral. But we've done quite a bit of that, comparing the cadastral to the census data. So you get it's a really good, reliable source. So it's a way you can sort of double check the validity of some of your cadastral.
Interesting. Be a neat check to do. Thank you. Other comments or questions? Let's see what, if anything, we can extract from this presentation on error, which is not my presentation. I stole it. Where did it go? Here we go. So I actually went to, well, there's a couple of things I want to show you. A couple of files that are both on the disk and on the laptops that you should be aware of. One is the ACS 5-year tech docs. It's a PDF file. And there is an appendix. I believe it's E. Yes. Appendix E lists all of the variables and their title, definitions, and whether or not they're available at the block group level. So you decide, I want this variable. I know it comes from ACS. Then the question is, can I get it at the block group level? Check the tech doc. In these tables, it will tell you. Another thing you can do is pull down a table shell, which you have to find this under the user documentation under the ACS website for the 5-year data. There are spreadsheets that list the table shells, and with this, you get the individual variable name and definition. so that you can actually go and search in here for, you know, heating. Why is it not finding that? Is it because I didn't type it right? Well, oh, because I had the field highlighted.
Yeah.
So you can go through and it'll find the variables just like you would with a real software tool. And once you, oh, it's not that one, it's not that one, it's not that one, not that one, or that one, blah, blah, blah. Oh, here it is. You can say, oh, I need B250-40-002. And if you need to know what series it is, it's over here. It's in table B250-40. That's house heating fuel.
How would you use that?
You can use that by going into Fact Finder and putting in that table name, and it will pull it up that way. You can either put in home heating fuel, and it'll search that way, or you put the table name, and it will pop it up more quickly. So.
Table name is the column A?
Column, yes, column A. Okay, so error. Let's see if there's anything in here I can pull out that is actually worth looking at. Okay. I guess when I went through this, there are a few things that were emphasized for me as a geographer during the census, and there are lots of different types of error. And rather than go through this and talk about these, I think this PowerPoint is worth going through if you're going to be serious about utilizing census data, particularly ACS data, because it talks about sources of error and the margin of error and the different types of error and how it's calculated. So if you go through this thing, you know, it'll give you an example to help you understand what they're talking about, and then it'll help you conceptualize it. Oh, that makes sense. And then you know, talk about standard error, margin error, confidence interval, coefficient of variation, and actually goes through the process of defining it for you. Some of it becomes a little hard to follow, but a lot of it makes some sense when you read it. So I would recommend this one. I found it as well on the documentation page for ACS, not Fact Finder. American Community Survey has its own web page, and it was under the documentation for the ACS. But you also have it in your data if you just don't want to worry about that, or you do have a disk available to you. There was a slide in here I thought was particularly useful. And I talk about pop limits here. Yeah, confidence intervals about comparing the data from year to year. Again, a lot of good stuff on comparing the data and the confidence and margins of error. You know, if you're going to spend some time with the data, I recommend going through it at a minimum, just to see if it has an impact, or maybe you should adjust perhaps the way you're using the data. So I'm running out of steam, which is why I'm not saying anymore. So I'd like to stop at this point and allow for any other questions or comments before we wrap it up for the day. Everybody's probably as tired as I am, if not more. Most of you were here this morning. It is a full day. So unless there are other questions, thank you very much. Appreciate the invitation to come here today.